Hey guys, welcome to this session on blockchain. In a world where digital currencies are slowly overtaking regular transaction methods, blockchain has emerged to be the best technology for a safe and secure digital currency management. In this session, we shall talk about cryptocurrencies. At first, we'll be learning what is a blockchain technology and how it evolved. And then moving on, we'll be learning about transactions in a distributed network. Then we'll be learning about the security aspects of a distributed crypto network using hash functions and Merkle trees. After that, we'll be learning about basic parameters of a consensus mechanism. After learning that, we'll be moving on to proof of elapsed time and sidechains. And finally, to conclude with the session, we'll be learning about Bitcoins and Bitcoin blockchain wallets. That's all about the agenda. Let us move on with the session.
As we know, the blockchain term has arrived and become very popular in past few years. What is actually it is? So before moving to that, we should know how our trading units transform from past to current modern exchange systems. We are well aware of barter system, okay, where utility things were used to make sell or purchase of items. Then it then came era of subjective ledgers, mental accounting, where things were recorded on ledgers for making sale and purchase of items. Then came physical objects, where we started exchanging the things that we have in return of the things that we do not have from each other without interference of third parties. Then gold and other assets were part of currency system or trading system for long, where golds or other assets were used to sell and purchase of items, and these were used even nowadays also. These are used as universal ledgers and form a basis of currencies of many countries, or you can say form a basis of economy of many countries. Then the current era came where paper money or fiat money system was used primarily to sell or exchange items among each other. Then we know we advanced in trading systems and we started using virtual money using online banking, cards, debit cards, ATMs, and other e-wallets also exist in current days that make our transactions very much easier. Then corporates also use their inbuilt token system, or you can say their own kind of exchange systems inside their organizations for buying like meal, their certain facilities, maybe their shopping carts and other things that again constitutes a trading system where they record their transactions and their values in form of corporate tokens that are specifically allowed and designed for that corporate or organization. Then the future, or you can say modern era, comes where Bitcoin or decentralized digital money is being used to transactions, purchases, or sell over the network using virtual money. Bitcoin in current scenario, if we discuss, exists equivalent to our dollars, pounds, and other standard currencies, and is very well recognized to do online transactions. And it has very much good value as compared to your dollar that makes the whole currency system workable. So let's see what Bitcoin is. Bitcoin was derived from your computer's smallest unit, your information system's smallest unit, bits. How it was named as a Bitcoin? Because it was a programmable money or programmable currency. So that's how it got a name called Bitcoin. And when we try to define it, it is a type of cryptocurrency which is nothing but a digital money. And the underlying technology that enables moving of digital coins or assets among individuals is blockchain. And Bitcoin was the first ever implementation of blockchain. And that time people thought that only cryptocurrencies can be built and run over blockchain. But as the things moved year by year, people started understanding that blockchain can be used as a universal network where all kind of information can be stored, exchanged in a distributed manner in form of distributed ledgers which are immutable, secure, non-hackable, and easily auditable whenever required, which give huge level of transparency that our current system do not have. It removes mediators that are present and impacting badly our current financial or other kind of systems. So these all benefits came when people started understanding what blockchain actually is. So let's see what the blockchain is. As we already discussed, the blockchain is an incorruptible digital ledger of economic transactions that can be programmed to record not just financial transactions but virtually everything of value. So what does this definition means? Does blockchain stand for only financial transactions? No. You can store and propagate any kind of information that you want to store and use on your blockchain network. So your blockchain network is not really limited to financial transactions such as Bitcoin or maybe other cryptocurrencies. So if we say in broader terms, blockchain is simply a data structure where each block is linked to another block in a time-stamped chronological manner. Each block has its timestamp of creation and the transactions that constitute this block. These blocks again stored in a chronological manner according to their according to their creation time. Second point, it is a distributed ledger, digital ledger of an immutable public record of digital transactions. This means the information is stored in multiple digital ledgers, distributed digital ledgers, which have same copy of information stored and immutable and cannot be changed once recorded. Every new record is validated across the distributed network before it is stored in a block. So when we say a blockchain is a self-sustained, self-validating network, so validation becomes an important and integrated part of any blockchain network. Every block that is going to be written in the existing blockchain should have gone through a standard validation process before getting recorded in a block. During this validation process, your validators decide and record only good blocks. The bad blocks are discarded, and that's how your blockchain kept safe and secure. All information once stored on the ledger is verifiable and auditable. You can anytime go and check your blockchain network. You can traverse through it and verify and audit any information that is recorded. Each block is identified by its cryptographic signature. We know that all blockchains have distributed ledgers which are owned by different nodes. So the information is not available in a plain format. Everything in a blockchain is stored and saved using cryptographic signature, or in other words we can say in form of encrypted information only. The first block in any blockchain that you develop or produce is called Genesis block. The Genesis block is the very first block that you have to create, and at position 0 if we talk about length, and that should be the point where your whole blockchain starts and other blocks in that blockchain start following that Genesis block. So definition of blockchain, as we already discussed, Genesis block will always be your first block in any blockchain network when you are designing it, developing it, and start using it. So the other blocks in the network follow this Genesis block, and every block in the chain identifies the previous block using its block ID, or you can say hash of that block. So this way, every next block is aware which block to follow or which block is following itself. So to access data of the very first block created, you have decussate from the last block created to the first block. Okay, so at any point of time, if you want to traverse the blockchain network, you can start from the last block, and you will be, if you follow that, you will be successfully able to get your Genesis block and the length of the blockchain. Sounds good? Yes, so this is the one of the interesting feature of blockchain, where it know what there is. Every block knows who is their ancestor following him. Then how blockchain tectonic shift happened? Sorry, how blockchain tectonic shift or roadmap we can assume from now. The 2017 started as a golden period of blockchain, where venture capital flows $10 billion has been invested into Bitcoin. Everyone started recognizing the power of the blockchain. They started using it, and now everyone thinking how they can utilize the features, immutability, securability, your non-hackability of and other features like removal of mediators, peer-to-peer transactions. These are all very good features that everyone in industry want to use blockchain for their businesses. And then everyone started investing into the Bitcoin and blockchain, and the amount of the invested into the blockchain, so Bitcoin in 2017 was $10 billion. That started moving it at very faster pace in the market. If blockchain grows with this pace, that we are really sure. So by 2023, we can, which we can say a development phase of blockchain, age of consortium, alliance, and governance, Gen X platforms can come on the blockchain network and start leveraging the features and services of blockchain. Again, by 2024, the blockchain inflection point can attain critical masses, can become integrated part of many organizations. By 2025, point of no return, we see that most of the organizations have already moved to the market and already moved to the blockchain, and they are not in mood to return from the blockchain. Okay, so just to summarize, you can take a scenarios like by 2023, your government may start collecting tax on blockchains. 1 trillion IoT sensors could be connected to the internet. Digital transformation of outreach of 80% of population. Your your masses and population shall start receiving things digitally. 80% of the population should start leveraging the features of digital technologies. By 2025, sharing economy 2.0, P2P economy, and can become peer-to-peer economy can become very famous and can become integrated part of the sharing. You may have smart city fully operational based on the blockchains by 2026, and by 2027, 10% of the world GDP will be on blockchain technology. So this is the assumption based on the current growth rate of blockchain and the awareness that people are trying to invest and utilize the features of blockchain in their businesses and to make the world and their countries a good place to live. Before we know how blockchain benefits us, we should know the current system. Why we need blockchain when we already have successful running current system behind all required needs and services. The current system works that we use in our day-to-day life is for trading, for selling and buying items that are recorded in offline ledgers where transaction details are stored. Bookkeeping is isolated and closed to public. The public do not have direct access to the books, and for this reason, we need a trusted third parties or middlemen that we trust and they help facilitating the services, whether it is library, whether it is trading, whether it is shopping, buying over networks, maybe Amazon, maybe Flipkart, maybe other shopping sites that really requires a middleman to shop and purchase over the network in current scenario. So if we see, most of our services require a middleman to be utilized. So on and on, we see below challenges with the current systems. Banks and other parties, or you can say other third parties, take fees for transferring money. Nothing is free. If you involve a third party, they will not work for free. They are going to charge, they are already charging a good amount of money that is an overhead on the system. Mediating cost, again, increasing the cost of transactions. Things are becoming costly for us. In any ways, end user has to pay for any services they are utilizing. It's not their organization is going to pay. So ultimately, things are becoming costlier for us, the consumers. Minimum practical transaction size is limited, cutting off the possibility of small casual transactions. Financial exchanges are slow, checking and low-cost wire services take days to complete. International cross-border transactions really require good amount of time for any transaction to complete because of current existing systems of middlemen or mediators. System is opaque and lack transparency and fairness. We don't know what is happening behind us, what is happening with our money that we are spending in banks. We are investing in banks, we are investing in stock markets, and that's how system is completely non-transparent to us. Also, the central authorities that are controlling the system, currencies, maybe from banking, maybe from stock markets, maybe from other institutions, are have completely have chances to overuse the power they have and can create money as per their own will. Even every country's currency system is being managed by their own banking institute. Okay, so these are some of the current problems. There are more, but these are few major issues with the current systems that are motivational factor behind use and utilization of blockchain, because your blockchain helps overcoming all these problems. What could be possible solutions? We need a system which eliminates the need of middlemen or third parties, thereby making transaction cost nil or negligible, right? If there's no middleman, we don't need to pay him. We can save that money and make things cheaper. Enhance transaction execution speeds and can facilitate instant reconciliation. Again, is transparent and tamper resistant in order to avoid manipulation or misuse. If things are transparent, no one with or without authority can tamper the information and do false transactions for their own benefits. Currency creation is not in control of any central authority. If you see, we are on a blockchain or similar network, there is no central authority who can impact the system or example currency generation for their own benefit. This can also help regulating and maintaining the value of currency. Things in current system sometimes go beyond control. Inflation cost may go very high. That is something unexpected with the current system. Things are not predictable as they should be. So using a system like blockchain will help regulating the currency, money, economy in a very expected and time-bound manner. So how distributed system solve this problem? Distributed system enables a network of computers to maintain a collective bookkeeping via the internet. This is open and is not in control of one party. It is available in one ledger which is fully distributed across the network. So there will not be any single authority controlling the information and things are available in distributed ledgers, say computers or nodes. So how distributed system looks like? You see, it is a environment or you can say network of connected nodes, say computers, servers, peers, or you can use any term that have their own computational power, storage, and logic to do transaction in a distributed system. So on and all, we can say a system where two or more nodes work with each other in a coordinated fashion in order to achieve a common outcome is called distributed system. All nodes, all computers in the network should be serving a common goal. If they are blockchain system, cryptocurrency system, they have to be meant for financial transactions. It's modeled in such a way that end users see it as a single logical platform. For end users, the what matters will be the outcome from the network. What they want to do, they should be able to do without any middleman. What is a node in the distributed system? A node can be defined as an individual processing unit in a distributed system. All nodes are capable of sending and receiving messages to and from each other. Nodes in a distributed system need to be connected with each other. Some may be directly connected, some may be connected through other nodes. So the whole purpose is that whatever information is flowing in a network should be able to propagate to every node without any specific delay or any tampering. So let's start with our third part of the video on the topic cryptocurrencies and blockchain. So during the last session, we discussed about what blockchain is, what distributed ledger is, distributed chess system, and the basic idea on Bitcoin. So let's see what kind of distributed ledger technologies are available nowadays. The picture on the screen elaborate many things about the platform used, the technologies, the consensus mechanisms, the application use cases, industry outcomes, consortiums about the distributed ledger technologies available nowadays. So major player in as part of infrastructure and technology providers are cloud vendors like AWS, Azure, Google, IBM Bluemix, etc. play an important role in providing infrastructure to distributed ledger technologies. Then they are needed to run blockchain infrastructure, providing sufficient and good amount of resources to run your blockchain transactions with a good speed and high accuracy. Platform technologies and providers are or can be divided into private and proprietary, private consortium, and open sources. Few are open to the market and can be utilized for as per the individual needs. Example of private and proprietary providers are Digital Asset, Nasdaq, Chain, Tendermint, Casper, etc. etc. Then your private consortium constitutes Corda R3, CEV, Sentinel, and then comes your open source available blockchain networks or distributed ledgers you can say called multi-chain and Hyperledger V1.0. Then there are multiple open providers like Ethereum, Stellar, BBFT, Bitcoin, Consensus, Paxos, etc. So on the top of the platform technologies and providers, there runs consensus mechanism to finally run your transactions and commit them into a new block. So there are various kind of consensus mechanism evolved with the evolution of blockchain technologies. Few are leader based, few are proprietary distributed ledger consensus based, few are federated consensus based, few require your very generic algorithms like proof of work, proof of stake, proof of elapsed time, and other mechanism to allow your validators or miners to create new blocks and give them chances equally to commit their transactions and write them into a new blocks. So all the consensus mechanism you see here, some or other way, helping validators to validate their transaction, record their new blocks in fair manner to the blockchain network. What actually consensus mechanism is, we will be learning in coming slides. Then what could be the application and use cases of blockchain networks? You can use them in trading finances, cross-border payments, commercial paper trading, digital identities, asset security tracking, document digitization, accounting and assurances, cryptocurrencies, tokenization, swap reporting, smart contracts, blah blah blah. So there are ample of use cases where people are doing their blockchain involvements and writing their programs to use them to use their use cases in blockchain network that can inherit all the said features of blockchain. There are various industry consortiums supporting this all development. One is Hyperledger V1.0, there is R3CEV, PTDL Group. These are some example of consortiums supporting this whole development and taking the blockchain to the industries and other required destinations. Now, let's discuss about transaction in distributed network. How a transaction happens. So, suppose James wants to transfer some money to his friend Kevin. How it will go now? Now, since there is no central authority in the system, there can be certain questions that might come your mind, like who will be validating the transaction? Who will validate if James already has sufficient money? If during the transaction on the fly, the money was not lost, the transaction initiated was from James only, there should not be any chance of repudiation. When Kevin receives the money, it actually received the money. He cannot repudiate that he did not receive the money. So how these kind of scenario you're going to manage in distributed transactions? So as we already told, the term that consensus and you can simply say the validation algorithms help maintaining the consistency and the validity of any transaction that are happening inside a distributed network. So when James start any transaction to send money to Kevin, it goes through various validator nodes. They see, they run the logic and check the recipient and sender's address using their public key or other methods available that the sender is genuine, he has the required balance, and the recipient where the money is going to is existing in the network and is able to receive the money successfully. Also, there is no any duplicacy or loss of transaction while or before committing it inside the network. And while committing all these transactions and validating them, each participant will record the transactions once it is successfully published inside the network. So whenever you go to a blockchain network and validate or audit the ledgers, you will find same copy of information stored at every node. And if any node differs from other nodes inside the network, then it will not be allowed to be part of the network anymore until it recovers and becomes in sync with the other nodes. Now there will be certain questions in your mind. How to verify from where the transaction is initiated and what to and to whom it is sent. How is the transaction faster than the present system? Who validates the transaction as there is no central authority? And how is currency generated? There is no one funding the network. So how the new currencies are generated and how people are increasing their balances. So to satisfy your curiosities, first let's see how a transaction is initiated in a distributed network. Every participant in the network has their two pieces of information called public and private key. And those who are aware of public and private key know well that these are root items or root contributors of any cryptography mechanism or system. So while sending the money, James will encrypt or sign the information that he is paying money to $500 to Kevin, will encrypt the information and sign it using his private key. That will go in form of a cryptographic information, encrypted information over the network, and then when Kevin receives the money, he will use the public key of James and decrypt the money and have the amount. So this is how a transaction is initiated. There are multiple steps and phases through which a transaction is successfully committed to the network that we will be learning when we will see and discuss in more details. So just because we are discussing about cryptography and public and private key, I will just like to elaborate here on public key cryptography mechanisms that we use, and that those have become industry standard nowadays to keep our information secure over the open internet, because everything is online, and we and programmers are continuously starving to derive day to day, in even daily, on daily basis they are continuously fighting and trying to derive new technologies that can cryptographic technologies that can help keeping your information more secure, because hackers again trying to break your network and use your information without your authority, and they again try to weaken the network and the weaken the security system of any organization for their own benefits and own needs. So when public key cryptography is used, this can be of two kind: symmetric key cryptography or asymmetric key cryptography. So symmetric cryptography is not very much secure. So everyone uses asymmetric key, where you will be given where every user will be given two keys, pair of keys, in terms of private and public key. So out of the both keys, one is purposely kept private, the other is provided to the other parties, and that is called public. If you use private key to encrypt the information, then public key can be used to decrypt it. So if you use the public key to encrypt, then you can use public private key to decrypt, vice versa. Because two different keys are used for encryption and decryption, this is called asymmetric key in algorithm. So using this information, the person who is having your public key, and receiving the information encrypted by your private key will be in a situation to decrypt the information and ensure that it is you that has sent the information. This helps to maintain and identify the sender by using and decrypting the information using their public key. How these keys are stored? These keys are stored in form of wallet. These wallets could be a folder on your system, on your drive, online, or maybe a flat file you are storing the details. So wallets could be of multiple types for storing the keys used for the encryption and decryption. So every user or every node in a blockchain network will have their own wallet to store their keys, called key store. And this is not with the blockchain only. This is true for all cases where encryption and decryption are used. Your SSL, your TSL, your digital signatures, your Kerberos mechanisms, everywhere you need a wallet to store your keys, called key store. So Bitcoin addresses and wallet. How Bitcoin addresses are maintained along with the wallet. So an identifier of 26 to 35 alphanumeric characters beginning with the number 1 or 3 represents a possible destination for a Bitcoin payment. So if you see any string that is starting from 1 or 3 and length 2635 will specify a Bitcoin address. Any user that is holding a node in a Bitcoin network will have a Bitcoin address where or to he will start any transaction and participate in the Bitcoin network to earn coin and do transactions. Bitcoin wallet. A wallet is basically the Bitcoin equivalent of a balance or bank account. So when we talk about wallet in Bitcoin, it is equivalent to your bank account where you keep your whole money. So it allows you to receive Bitcoins, store them, and then send them to others. So like your normal bank account, you can store money and send the money whenever required to the other person. Once a wallet is installed on your computer or mobile device, it will generate your first Bitcoin address that you need to remember. Each address has its own balance of Bitcoins that it maintains and updates along with the transactions occurring. However, the addresses can be changed whenever you want to. These addresses cannot need to be unique. You can change when you want to change your system or place. There are various kind of Bitcoin wallets available in the market. There are software wallets available, like Bitcoin Armory is the most popular, stable and secure software wallet that is used nowadays. There are web wallets available. Web wallets add a level of convenience that software wallets can't, such as being able to access your funds from any device. So using web wallets, you can access your funds anywhere and do transactions inside the Bitcoin. Cold wallets. Cold wallets are simply any kind of Bitcoin wallet that isn't connected to the internet and that can be used to do the transactions. Then comes your paper wallet, USB drive that can be used again on the go. You can take them with you and participate in the network whenever needed. Then there are brain wallets available. When you don't want to keep any wallet and keep the passphrase in your brain, you can use them and remember in your memory to do the Bitcoin transactions. Then comes hardware wallets that can only be accessible with the physical contact to the wallet and have hit the scene this year only. So considering the requirements, Bitcoin has given the facility of hardware wallets that can be used and kept with you like physical identity like cards, and then can be used to do the transaction inside the network. So till now we have discussed about basics of Bitcoin, blockchain, distributed ledger, and about a transaction initiation. Now let's know what transaction is. A transaction is a piece of information that you want to share in order to update the existing items or generate a new items in form of transactions and block inside the network. So while sending a transaction, you follow your system or network follow a mechanism of modifying the information or generating encrypted entities in order to keep your information safe. The transaction is broadcasted in the form of a digital message, as you can see in the picture, and just like your signatures provide the proof of ownership on the document, similarly, digital signatures provide the proof that is transaction is genuine. Unlike a handwritten password, digital signature is unique for every transaction. So what it means actually, whenever you are sending information, transaction details are hashed using your private key, and these are treated as a signed message authorized by you and sent over the network. The recipient knows your public key, gets your message, uses your public key, and decrypts it further to get the hash value of the data information sent over the network. Now, this hash value is regenerated at the receiver end using your key and checked if it is same for the data or hash value that you already sent with your information. So this is how sender and receiver maintains the integrity of message by hashing the data they are sending over the network, by signing with their private and deciphering with their public key, and then guaranteeing the information by using the hash of information. Because has the property that for any certain given string, it will always generate a unique value that can never be changed until provided string is changed. This is how hash is used to guarantee the information is not tampered or changed while transmission. Even if a dot is changing the information, your hash value will change completely. So how transactions are propagated over the distributed network? How are the transactions are faster than the present system inside distributed ones? What happens when you do transaction in current system? You may be connected at a significant distance with your recipient. So the network delay will cause the whole delay on your transaction, and that can be a significant amount of time. But when you transact in a distributed network, in a distributed architecture, transaction is transmitted peer to peer. Transmission of the transaction across the network takes around 1 and 2 seconds only. So every peer node helps you propagating the transaction over the whole network and collectively help passing the information to each and every node inside the network so that every node has updated information inside the ledger. This way, information travel faster than the current existing system. For example, take a scenario where a node in the network finds a transaction that Kevin pays 5 coin to James. So now what it does, it passes that information to the very nearby B and C nodes that are connected to it. Now, B and C will pass the information further to other nodes that are connected to it directly. And similarly, other nodes will do until all nodes are covered. Hence, this way it is faster and cost efficient as there is no middleman and the propagation takes lesser time than the existing system. Now, when a transaction is submitted, who takes the responsibility of validation of the transaction because there is no middleman? So now the question will arise in your mind. When there's no middleman, there's no authority to validate your transactions, how transactions are being committed in the blockchain. Who will take the responsibility? Or if there's no one, how developers or blockchainers are writing the codes to make it automatically done? Let's see. There are some special nodes in the network who verify the transactions and maintain the ledgers. They are called miners. So miners are basically responsible for keeping your data validated before recording into them in a new block. So these validators helps creating new blocks based on all the conditions met as per the logic written. So they also helps to find good transactions and bad transactions. They remove immediately whenever they find a transaction is bad and not following the standard. Since there are multiple nodes participating inside a network, there will be multiple transactions to be validated every time. So what validators do, they keep checking for the transactions, they group them in the new block and then validate all the transactions and then try to generate a new block and put it into the network, and that increases every time they do, that increases the length of the blockchain by one block. So when you write logic for your blockchain validation, new block validation, you need to be careful that it should include all logics that you want your validators to perform during the validation check automatically. So your algorithm or your code should be smart enough to do this all without any human or physical intervention. So miners are what miners are called. Miners are special nodes which hold the copy of the ledger and verify the transaction happening in the network. Using state-of-art cryptographic algorithm, miners validate the transaction across the network. They are responsible for creating and committing new blocks in the existing blockchain. In order for our digital monetary system to work, the miners must be able to confirm that the originator of the transaction possesses the fund being transferred. The originator of the transaction has obtained the funds by one of the means commonly recognized as valid. So they perform all the required check. If this is a financial transaction, they are responsible to validate if the request is coming from a genuine node, which is actually part of the network. And how they do? They use a public key to validate the sender. Same way that they do for the recipient if the recipient exists by using the information shared by the each node inside the network. So they also inquire about the funds that to be transferred, that they are sufficient and available in the wallet of the sender node. Once they find all situations satisfactory, they run to create a new block inside the network. Verification. How to verify whether transaction is initiated and to whom it is sent. So, as already told, that digital signature is used in transaction verification. Every node that is initiating the transaction uses his private key to encrypt the information he is sending over the network, and that information majorly includes the details of the transaction, what he is doing, to whom he is, if he is sending a money or bitcoins, to whom he is sending, and that those all information are kept in a block, sorry, in form of data, and that is being signed by the sender with his private key to make a digitally signed signature. Then this information is propagated from the sender node to other peer nodes, and then the validators use the public key of the sender James, say, to decrypt the information and defy if it is being sent from James only. This way, they authenticate the transaction and the sender and recipient of the corresponding transactions. So, once transaction is validated, how it is stored onto the network? Let's see. Once the transaction is verified, it is stored in a shared ledger across the network. How it does that? It keeps appending the informations to the existing network in the form of blocks. And if you see from the figure, each node should have same copy of the information, and any node that is having different information and not concurrent with the existing blocks nodes will be removed from the network. So each block of information is appended and replicated across each node inside the distributed ledger. Here in the example you can see James, there are three transactions. James sends $5 to Kevin, and that is be recorded in the ledger of each node. James, Kevin, Robert and Paul. Then Kevin transferred $3 to Paul. That is also you can see recorded, and then similarly other transactions will also be recorded in each ledger, or you can say nodes ledger. Now, ordering of transactions. Since transactions are passed from node to node, there is no guarantee that the order in which you receive them represents the order in which they are created. Quite possible, because there are multiple nodes participating in the blockchain, and there may be any number of nodes initiating the transaction in the network. Then no one can guarantee that they are maintaining the order while being received by the validators without creating a strong logic. To agree about the transactions order is a challenge in a decentralized system. Therefore, the cryptocurrency system orders transactions by placing them in groups called blocks and then links them in a chain. How they do it? They group the transactions on the basis of their timestamp of generation in a group. They call it a block and then they create a new block and commit it into the blockchain network. So since we know now how transaction is initiated, how it is recorded, validated, and then stored in each node's register, we need to understand how miners group the transaction into a block and how they commit them into the existing blockchain. From the figure, you can see that there are multiple unconfirmed transactions. You can see new transactions that are not already committed to the block or blockchain that constitutes, for example here, Lisa sends Sandra 7 Bitcoin. Mary sends John 10 Bitcoin. James sends 5 Bitcoin to Kevin. Now, there comes a validator node which picks all these transactions in a group. He writes a block like you can see here, and then they form a new block with the information of previous block, creating the new ID for this current block, and then start committing them into the Bitcoin network. One more important thing is that you should observe from the diagram is every block has a number attached to it that corresponds to the length of the blockchain and block ID of every block created in the network. And the most important, the relational thing is every block is maintaining the hash of the or ID of the previous block in it. And this way it really helps to maintaining the integrity of the blockchain, and since every block remembers the address of the previous block, no one can inject a new block between any block in the network. This helps keeping your blockchain immutable and unhackable, you can say. Now, there is a chance, and this happens practically, like when your miners are creating a block in the network, they will not be alone participating for creation of or mining of a new block. There will be multiple miners working to create a new block. And that is where you need to write logic, or you should need to have mechanism where various miners are constructing blocks. There could be several options to choose from. How does the network decides which block should be the next in the chain? How you'll be deciding which validators block the network should choose. So again, there is a logic in Bitcoin, existing one, and while you are writing your hyperledger, you need to be when you're writing a logic for your blockchain, you need to be very conscious while writing this logic, like how miners will behave and how their work will be picked against others while writing new blocks. So there can be number of miners constructing a block that we already know. Now we need to see which miners blockchain should pick and write. So for the sake of this, for the sake of the integrity and selection of a new block, there are certain mechanisms defined by every blockchain technology provider, whether it is Ethereum, whether it is Hyperledger, whether it is Sawtooth, or any available blockchain network or blockchain platform nowadays. So few are like proof of work, proof of stake, proof of elapsed time, and PBFT. These are certain mechanism, or you can say algorithms, that helps the blockchain deciding new upcoming block in the network. So let's see one example of proof of work, how it helps deciding the and selecting the work of a validator in form of a new block. Proof of work is a piece of data which is difficult, costly, time consuming to produce, but easy for others to verify, and which satisfies certain requirements. To keep the coin distribution predictable, puzzles become increasingly difficult to solve when more people work on them. Part of Bitcoin solution is that each block must contain the answer to a specific math solution. So, since we are concerned about how new blocks are picked, so proof of work is an example of doing so. Now we'll be discussing how, out of multiple validators, blocks will be selected and added as a new blocks in the blockchain. So, in our last lecture, we saw that proof of work is one mechanism using which Bitcoin and some other blockchain platforms decide out of multiple validators which node to select for new block creation. So, let's discuss proof of work in detail now. What proof of work is? Every node, every validator node must say, given a task, given a work to find some value, said nonce, in order to calculate and solve the problem or algorithm given by the blockchain network. The winner node is given a chance to create his own block and add it to the existing network and then publish to all other nodes that the block creation has been done successfully by him. So Every node has been given the same problem to solve, and then they start working on the solution of the problem, and depending on their resources and processing power, they try to solve the problem first. The winner node gets a chance to add his block to the blockchain and becomes the winner and get awarded by the Bitcoin or other mechanism in the different blockchain networks. So how it works actually? This algorithm, or you must say a puzzle that has been given to the nodes, varies in terms of complexity depending on the size of the blockchain. If there are more validators competing to perform the calculation and solve the problem, then the puzzle becomes more complicated and it becomes increasingly difficult to solve when more people work on them. To describe in more detail, we will take an example of some sort of problem that may be given to the nodes, validator nodes, in order to solve and create their node. Suppose the problem is to solve is there is a string, say hello string, and how it works, each validator need to calculate a nonce, say n, that should generate a string where the hash value of it should become should be less or equal to 2 to the power 240. This is just a number. We are just trying to analyze a problem that can be given and how proof of work actually works in order to decide the winning node. So the string and other things may simply vary, but the problem lies similar to this. Each node now need to guess the n value in order to win the puzzle, and for which the value of hash of this whole hello plus n should be lesser than 240. They start calculating it, say from 0. N is again integer, so they should be starting from 0. So the whole string becomes hello 0, and the hash of it may come around 2 to the power 252, say. So this is not the right choice. We need a value less than 2 to the power 240. So now the node will do, what they will do, they will try on value 1 of n. So they do the hash of it, and that may become maybe 2 to the power 272 somewhat. This is again not true. We need a value lesser than 2 to the power 240. Suppose it goes on now, and at certain point they get a value n, say 98. By hashing to that, we get a value, say 2 to the power 239. Now this satisfied the situation where the n is equal to 98 gives you a value that is less than the required condition given. Okay, so this is how the node that gets the value n first will be the winning node and will be allowed to create the new block in the blockchain. This is an example of proof of work. There may be other puzzles, complicated puzzles might be given to validators in order to solve the puzzle and become winner. So as we discussed, as we saw in the example, there are three components which help in achieving the proof of work solution. One was nonce, that was the value that we had to guess in order to get the required solution. In technical terms, if we say a random number whose value is set so that the hash of the block will contain a run of leading zeros, the rest of the fields may not be changed as they have a defined meaning, right? So the fields or the string was given hello in our example, and we kept calculating the value for which a given criteria is met. Second important thing is hash, a fixed length number which result in large unchanged data when read. Okay, so that was the value of the nonce plus string that we calculated a hash upon and tried to find the result. Third is transaction, authentic transfer of Bitcoin ownership collected and recorded in the blockchain. So this is how proof of work actually help creation of new blocks by deciding the winner out of the multiple nodes, validator nodes in short. Now, how a blockchain network decides on the puzzle? Why is it hard? The moment you keep increasing your network, your validator nodes keep increasing. So how you do it? The SHA-256 is a one-way function. Hence, the brute force is the only way to a particular output value, meaning it is having combination of 256 keys where it becomes really very difficult for a attacker to find a solution or find or encrypt the function's value and get the actual data. On an average, it makes many random guesses to find a solution, and thus the challenge is tough. It takes around 10 minutes on an average for someone to find the special key for the solution. So, since it is having 256 key combination, so it takes much time, resource, computation power in order to find the result. Hence, a new block in Bitcoin example generated every 10 minutes, not before that. So this is how your proof of work actually helps. But if we analyze in detail, the proof of work becomes a very resource extensive and time consuming problem process. And in this way, this really requires huge computing power, and obviously a node which with high computing power will get a chance to win again and again over other low computing nodes that are available in the network. How this can be overcome, we will see later on. But this is again, despite of few limitations, this is again a strong solution that exists in blockchain like Bitcoin and others to be used to decide the new block creation. Security problems of hash functions. Now, how hash functions help deciding the security of the data. First of all, it is collision free. What it means, if you are given a string, even a character A suppose, then hash of A will always be unique. Means if you have been given a hash of value A, then you cannot get another value B or C or anything which can generate the same hash value. That means to generate the same hash value of anything, it has to be that thing only. That means hash of A can be equal to hash of A only. It cannot be hash of B. Second, hiding. A hash function is hiding if when a secret value R is chosen from a probability distribution that has high entropy, then high Rx, so it becomes infeasible to find X, means concatenation of two strings. Means if you're concatenating two strings, then the value again, the hashing value becomes different, and it is really difficult to find the value of X that is changing that string. Third, it is puzzle friendly. For all probable value, output value B, if M is chosen from a very high spread probability distribution, then it is not feasible to find the hash value of any given function, say W plus DZ equal to A. So hash is very frequently used for creating puzzles and to solve them in blockchain networks. Now the bigger question comes, why when validator nodes required to invest high amount of energy, computation power and time, then why do they participate in mining of the new blocks? This is why, because they are given incentive in return to the creation of successful block. So example in Bitcoin, every winner block is a winner block node is awarded with the Bitcoin. In other blockchain also, there are mechanisms to award the validator nodes and result to the creation of new blocks. Minus reward. What do they get to do? What do they do to get this? Minus tries to find the key to the complex puzzle, as we have already seen, right? Search for this key is random. Hence, a miner needs to invest huge computational power and energy. The miners are repeatedly guessing new keys until the first key is found that matches the puzzle. That is the nonce. The miner who finds the key publishes the block to the network. All this happens and we have seen already. Other miners stop creating the blocks and will take the published block, validate it and add it to the ledger. So the published new block will be added to all, will be published first to the network and all nodes will take it, validate it and add it to their ledgers. In the diagram, you can clearly see new blocks are appended at the end of the blockchain network. Now the reward. Since miners use their valuable resources to validate the block, they are given monetary award. In case of Bitcoin, they get some newly created Bitcoins as award. So every new generation of block creates Bitcoin and the validators of the nodes get rewarded in terms of Bitcoin, and this is the reason they take interest and help and participate in creating new blocks. Exhausting resources to solve the puzzle means the miner has actually solved the puzzle proof of work. That is why it is called proof of work. They are spending time, they are spending resources and getting the solution that proves their work. The diagram, you can say the amount of electricity and computational work they do is equal to the monetary award they receive. Now we will see how new currencies are generated in a blockchain network, say Bitcoin. So we know the generation of transaction inside a blockchain network and their validation by the validators and the winning blocks. This whole process helps creating new blocks, and in return the new currency or new coin is generated and awarded to the winning node. So how this all happens? Currency generation. As a result of incentive to miners, new bitcoins are generated and sent to the miner's address, that is, their wallet. A predefined schedule limits the number of bitcoins so that they gradually approach a total of 21 millions. So, if we talk about Bitcoin, only 21 millions Bitcoin can be generated as per the current hard-coded value in the Bitcoin blockchain network. So, this value is hardwired in the protocol, and in current scenario, it cannot reach above 21 millions until the value is changed by the in the protocol itself. So currencies are generated as a result of winning and creating a new block in the blockchain and in form of reward. Now we have already seen how proof of work actually helps creation of new blocks and result of generation of new reward money. So what happens? There's another scenario. There may be more than one validators that may be able to solve the problem at the same time. And in this way, more than one block may get solved in the same time. So what's the problem here? I have understood that the first miner to provide proof of work will get the reward. What happens in the case when more than one block gets solved in the same time? Yes, this is possible. Maybe two nodes have same computational power and luckily they get to solve the problem in the same time. And if the such scenarios result, then these can be solved by consensus rules. Now, what is consensus? How it is built? Now, in layman term, if we talk, consensus is something where all nodes reach to a point of agreement and agree to submit only one node as a result of new block generation. How consensus algorithm should be written? Consensus algorithms are central to the functioning of any blockchain because when multiple blocks working, becomes very common that multiple nodes may be able to solve the problem at the same time and you get multiple new blocks to be added to the network. Now that time you need to decide which node you give the preference. If there is a contradiction among the nodes about the blocks in the network, such a contradiction is solved by the consensus rules. Now these could be consensus is the task of getting all processes in a group to agree on some specific value based on the votes of each process. With a consensus algorithm, we need to give unanimous agreement from all nodes to submit and decide a winning node. Any algorithm that relies on multiple processes maintaining common state relies on attaining a consensus. Okay, so how it happens? Every node have to be agreed on a value by a voting system or by some similar ways to reach on a consensus and decide which node will be writing his block to the new blockchain. And if this scenario arises, there will be several branches participating to create the block. Although the problem is tough, however, there are chances that more than one block will be solved. Several branches in the blockchain are possible in such cases. Right, like if you see in the picture, these three nodes may be solved at the same time and may try to add their block at the end of the blockchain. And if some other nodes are also generating at the same time, so they may consider the generated new blocks as the last branch of the last block of the blockchain. And they may again start adding their nodes behind the new ambiguous blocks. So what happens? Everyone should simply build the blocks on top of the first block that they receive, and that creates branches in the blockchain. So other nodes may have received the blocks in different order. They will be building on the block they first receive. This keeps happening, and the blocks may get added to all three branches. Now, what algorithm will do? Say from the example, you see Paul received a green block first, hence he builds the next block on top of the green. What Robert does, he added orange block first and then he keeps building his new blocks behind that orange node. Then what Lisa does, she got new blue block and hence she will start building the new blocks behind that blue block. Now what happens if blockchain consensus tries to solve the problem? It will try to solve the problem by finding the longest branch. What statement says? The tie gets broken when someone solves the next block becomes because it is very rare for this solution situation to happen multiple times in a row, right? What it does, it will find the longest branch and then in order to stabilize the situation, it will use the longest chain available as the main branch of the blockchain network and discard other blocks to try again and get added to the network. If you see from the diagram, Paul, Robert and Lisa have to be agreed on the longest blockchain that Robert created. Now blockchain quickly stabilizes. Every node is in agreement with the current state of the ledger. Everyone writes their ledger with the current block's details that are newly added to the system. Now what happens to the transactions in shorter branches because they were valid transactions. They were formed from the winner blocks, winner nodes. So how they will be, whether they will be kept or discarded, let's see. Such transactions go back to the pool of unconfirmed transactions and will be picked later in the block by the miners in order to commit and hence these won't be discarded from the network. If you see from the picture, it says transaction in the shorter branch lose its place in the logger chain and transaction then go back to the pool of unconfirmed transactions and will be included later in the block. In this way, none of the valid transaction will be lost from the network, maintaining the integrity of the system. Again, now, since everything is automated, there is no mediator, no authority, there are chances that some of the miners, in order to get awarded, try to cheat the system. How blockchain prevents cheating inside the network? Since there is a reward for solving a block, there are chances that miner might give a wrong solution to the block. What happens in such cases? After creating a block, miner has to publish the block within the proof of the work to the network. Other miners now start validating the block to ensure the authenticity. Means the winner block will not be simply submitted to the chain. It will be validated by other miners who were participating and lose during that time. If the proof of work provided is wrong, the block is considered to be invalid. As a result of which the miner end up exhausting their resources without getting any award. So if miner tries to do that, tries to cheat the system, he will fail, and if he fails, he will not get any reward. That will lose all his effort and energy that he invested in cheating the system or creating a new block or wrong solution. Once he did not get anything, he will never try to work again and give a wrong solution. This way, none of the validators try to cheat the system, and therefore the consensus algorithm does not allow anyone to cheat the system. This way, you can say here blockchain is cheat proof. Since now we have learned how mining happens, this is a just glimpse of whole process take place during the mining of a new block. Select the header of the most transaction recent block and insert into the new block as a hash. Now, what is happening? Here comes a miner which bundles all the transactions in a block and then verify if the transactions are valid. Once it finds the transactions are valid, it will select the header of the most recent block and insert it into the new block as a hash. Now, it will solve the problem by using the proof of work, and if when the solution is found, the new block is added to the blockchain and propagated to the network to be aware of everyone's knowledge. Now, second problem, how blockchain saves from the hacking. What if someone tries to alter the transaction in the block? Once the block is solved, the cryptographic hash output becomes the identifier of that block. And even if someone tries to hack, it will get. The block contents actually contains the previous block ID and transactions random guess. This way, it will give you a hash output. If someone tries to alter any transaction in any of the block, the hash of the block changes. And you're already aware now, if someone tries to, even a dot is changed in the given string, the hash value completely changes. And this way, the attempt to change the value of the node or block will be failed and no one can hack the system. And this way, if someone tries to hack the system and tries to alter the block, he need to change significant number of blocks in the system and arrive to a consensus of a certain decided amount, say 50%, in order to commit all his changes to the network. And this way it requires a lot of energy and time, and this becomes almost impossible by any hackers or any intruders to change the data of all the nodes or even 50% of the nodes to reach any consensus, and hence fraud can easily be detected. The validators will not allow any hacker or intruder to change the data of the nodes or blocks. Even if someone tries to do that, he needs to have huge computational power that is not possible in current scenario and needs only quantum calculation can help doing this. That is not possible in nowadays even. So if you see by this way, since quantum computational power is not yet available, it's under research phase, so there's no way to alter the system. If you want to alter any transaction in a block, you have to outrun the whole network. You have to make the changes in the whole ledgers, whole nodes, and it becomes really difficult, impossible actually, to change the data or transaction data inside the blockchain network. Now question arises, is it possible for someone with an extremely fast computer to outpace every other node? It is highly unlikely that someone can do that even with 1,000 of computers. Why? It would require more than 50% of the total computational power of the entire system to have a probability of solving 50% of the blocks faster than someone else. And that's, again, as I told, not possible in current scenario. It is highly unlikely to have a computing power stronger versus Earth and human. In order to sum up, the blockchain in a distributed system, transaction is encrypted by asymmetric cryptography, propagates peer-to-peer, are stored in a public ledger, is authenticated by miners or validator nodes, is secured by consensus algorithm. So these all 6 pointers sum up your blockchain technology and are significant pillars of any blockchain design and network, making it unhackable, immutable, secure, transparent, and distributed. We have already discussed about transactions, validators, miners, proof of work, and currency generation, and how the system is hack and cheat proof. So these all conditions and properties makes blockchain really secure in current and meeting the current market needs of security and trust that only blockchain can maintain. We already discussed the 6 pillars of blockchain that sum up and constitute blockchain technology, that asymmetric cryptography, peer-to-peer propagation, consensus algorithm, miners authentication and validation, and public ledger, distributed ledger, you must say. Now, what are the benefits of blockchain? For now, we should be able to understand why we need blockchain to implement our solutions and get the and overcome the problems with the current setup and current system of the problems that we already discussed, like middleman, like cost, like latency, like cross-boundary problems, and other things that we really want to avoid by using blockchains. How it helps, what are the benefits? Removing the reliance on a trusted third party to maintain a central ledger has the following benefits: settlement in real time, cost saving, security and resilience, immutability, user pseudonymity. We will see how these all benefits come from blockchain. So, in a nutshell, the use of mathematics to create a secure ledger enables transaction without the need of a third parties and hence access to shared single source of truth. There is no authority or control person to manipulate with your data side your organization by using the blockchain. What is anonymity and pseudonymity in cryptocurrency? Because your cryptocurrencies do not use their direct identity. Here comes the way they utilizes your identity in form of anonymity and pseudonymity, and how they do it. Let's see. There are two kinds of cryptocurrencies by going these identity terms, anonymous and pseudonymous. When we say anonymous, the state or quality of being anonymous, lacking a name, lacking individuality, an anonymous person is non-identifiable, unreachable, and untraceable. You don't know who the person is, where he resides, what's his address, and from where he is doing his transactions. So this whole property makes him anonymous to the whole network. So again, he will not bound to or link to any entity. Now, example, for anonymous dealings, unidentified individual telephonic an APP entity to inquire generally about its goods or services, and an individual completing a retail transaction and paying for goods in cash. Means a person using telephoning using an APP entity to inquire generally about goods and services, and then an individual completing a retail transaction and paying for goods in cash. So the person using telephoning you'll not be able to identify. He will just order and get the services. There are some examples of anonymous blockchains or identities, Homespring and others, Omegle, blogging and other applications you can see from the slides. And how it happens, how it helps being anonymous on cryptocurrency network. Being anonymous has its own rewards. It also adds value, but invisible exchange of values is a double-edged sword. because you never know what other person is doing and who is the person does that. Extremely valuable how examples some form of truly anonymous communication such as political speech are considered valuable. Electronic harassment into trades and business, this form of anonymity has exceptional potential for illegal acts because the message senders cannot be held accountable for their actions, and being anonymous makes it harder to trace transactions and giving higher level of privacy. So you can see here, being anonymous has advantages and disadvantages both, but for some currencies and some Bitcoin cryptocurrencies, it becomes valuable, and like Bitcoin and others, Zcash, these are building blocks and used for transaction as anonymous identities. So Zcash is again an example of anonymous cryptocurrency. First totally anonymous cryptocurrency it was, provides completely anonymity solution hiding all knowledge about the transaction. No one knows who is doing the transaction and what is the content of the transaction. It is a concealed value exchange, provides user with private access control to their financial information, and it is an application of ZK-SNARK's cryptography that uses anonymous identity. Only those with the correct view key can see the content. So to view the contents of the transactions, you need to have a public key of that sender. Users can provide view at their own discretion. Zcash is a very interesting technology, provided the security is not being compromised. So, as an anonymous cryptocurrency, Zcash has its own advantages and useful in certain areas. Then other kind of identity comes is pseudonymity. What pseudonymity stands for? It uses your identity, but not your real identity, but some pseudo identity given to you. Using a pseudonym to establish a long-term relationship with some other entity without disclosing personal identity to that entity. Example, your ID number or your employee ID in an organization is your pseudo identity. Hence, a pseudonym is a unique identifier, example, a nickname, credit card number, student number, bank account number, etc., that can be used to identify yourself. Using pseudonym, entity links different messages from same person, and pseudonyms are widely used in social networks and other virtual communication. Okay, like in Facebook and other social platforms, you use your nicknames to communicate with your friends and your networking peers. Importance of pseudonymity in cryptocurrency. All the transactions in pseudonymous network are open and visible to all, and thus it is widely acceptable. No financial organization or none of organization never want to do transactions and messages exchange with anonymous persons. So pseudonymity stands very popular in cryptocurrency network, blockchain network, and the transactions have origin and destination address, and hence the flow of money can be observed transparently. Illegal use of cryptocurrency can be tracked by careful analysis of metadata. So in this way, if you see from the diagram, A sends 4 bitcoins to B using his address. Okay, it currently has 6 bitcoin, and the A's address is pseudonym identity for A. It is not sending A on the network, it is sending his address as his pseudonym entity, and then network verifies the transaction using the keys and other things available with them, and then once confirmed validated, B will receive the 4 bitcoin from A to his payment address. That is again B's pseudonym identity. So this way whole thing works inside a pseudonym blockchain cryptocurrency network. Second thing is your cryptocurrency is programmable money, right? All bitcoins or other cryptocurrencies are generated by programming, by the result of transaction inside the blockchain network. Each unit is individually identifiable and programmable. Users can assign properties to each unit. Users can program a unit to represent a euro cent or a share in a company, a kilowatt hour of energy, or digital certificate of ownership, because of which the cryptocurrency is much more than supply than simple money and payment. It has vast application in number of areas that make them more useful than simple currency or payment system. Example of how cryptocurrency can be programmed. For a single transaction between two parties, programmable money can give the pair and pay a vastly greater range of parameters to use when exchanging value. You can always program your cryptocurrency as you desire, and you can add as many number of features that makes your programmable money or cryptocurrency more useful as per your need. It also enables a huge array of different valuables to be exchanged, far more than a conventional money, time, contracts, expertise, goods, services, and more can all be traded. Okay. So since it is programmable, you can add as number of modules, functionalities as you want. As an example, say Alice buy a car online from Bob. The payment will only be executed after the car has been delivered and passes an emission test. The term verification is completed by shipping agent and the emission test agent. When both are complete, then only transaction is authorized and the money change hands. It is very clear now, right? Until all the checks, all the tests are passed, transfer of fund will not happen. So these all condition you can write in your currency in order to propagate with validation and required checks. So apart from Bitcoin, is there any other implementation or cryptocurrency? Apart from cryptocurrency, is there any other implementation of blockchain? Yes. Affirmatively, there are various ways in which blockchain can be implemented. What are these? Although Bitcoin was the first implementation of blockchains was named or was recognized from Bitcoin only. The underlying technology behind Bitcoin was blockchain, and everyone recognized it after the popularity of Bitcoin itself. So many people even now understand Bitcoin is a blockchain, and blockchain is Bitcoin. Those who lack knowledge in this area consider both things as the same. However, if you want to utilize blockchain, we can utilize it anywhere. However, we need to think the cost consideration and the complexities before choosing blockchain for any implementation. Monetary aspect is just a tip of the iceberg of blockchain technology. Blockchain is a groundbreaking technology for which money is merely one of the possible applications. You can use wherever you want for finance, stock market, education, storing qualification data, industry flows, smart contracts, identity, asset, anything you want, you think you can use blockchain to implement. Like for industry flows, you can use blockchain for settlements, change of supplier, meter data, real-time capacity matching, etc. etc. Then for asset management, you have autonomous network configuration. You can use it for self-serve maintenance. You can use asset and inventory tracking, cross-asset industry data sharing. Then for entity management, you can use it for eligibility of social traffic, safety authorizations, permit to work, fraud detection, loyalty schemes, blah blah blah. So whatever you want, you can bring it on blockchain. Same for goes for smart contracts like EV charging, peer-to-peer trading, demand side management, network services, whatever you think you can implement as per your need. Blockchain gives you a platform. It's a concept actually, which you can use to derive the products by in your own language, known language that you want to develop and design the whole network. Now we will move to the next topic, delving into blockchain to understand more about blockchain and blockchain technologies. Database overview. What if we don't have databases? Databases, everyone knows, these are whatever transactions we do over the internet in our applications, offline, online, some or other way they are getting stored in databases if they need to be stored. Databases are being widely used for emails, for storing of emails, for caching reports, generating reports, exchange email sent and received via SMTP, IMAP and SMTP, response manager. Then one or other way, the single source of information storage is your databases. Nowadays, we have advanced database systems with no SQL, and that is again a backbone of our calculation in blockchains that we'll see how, but in later slides. What if we don't have databases? Did you know there exists an immutable and non-temporable database that is called blockchain, and it is also called distributed ledger, distributed database also you can say. How blockchain started? In 2008, Satoshi Nakamoto, an anonymous person or persons, can say group of persons, first gestated and implemented the first blockchain database as an infrastructure for the Bitcoin, the first cryptocurrency ever created and most successful of all the time. So, we already know Bitcoin was the first implementation or use case of blockchain. How blockchain started? Satoshi Nakamoto used block and chain separately in his paper in 2008 October. Later with the time, it became a single word blockchain, and that was meaningful also. How blockchains were evolved? Blockchain started in 2008 by Satoshi Nakamoto was the initial stage. In 2009, blockchain 1.0 evolved in form of cryptocurrencies and payment network. Then in 2012 to 2014, blockchain 2.0 evolved in form of assets and smart contract management. Later in 2016 to 17, blockchain 2.5 and 3.0 evolved. Blockchain 2.5 evolved as vehicle currencies, distributed ledgers, data layers blockchain, while your 3.0 evolved as programmable smart contract. Smart contracts are unable to access external data or events based on time or market conditions. Calling code or data outside of the smart contracts or blockchain breaks the general trust barrier and authenticity of transactions. Means smart contracts interact with the internal data only. They work on internal inputs and in order to maintain the trust and authenticity of transactions. What are smart contracts? This is just a name you have heard now, and later slides will explain you how and what are smart contracts. Blockchain, the flow diagram. You can see from here, individual transaction events occur on blockchain. The form of it, new block of transactions include a security hash of previous block that we already know, and blockchain new blocks are added approximately every 10 minutes in Bitcoin, and multiple computers mining servers check the validity of blocks in the chain. The quickest to check the latest block gets payment. That is called proof of work. You know that? And those who have not attended previous sessions, proof of work is a mechanism to allow one of the nodes, validator nodes, to win and to solve the problem, maybe mathematical problem or some other kind. And if it wants, it will be eligible and given a chance to create the new block in the blockchain system. So in return, it will get awarded and thus a new Bitcoin is generated in order to award the winner node. For successful transactions, that block is added at the end of the blockchain, and the other blocks that are not passing the transaction checks will be rejected and will not be stored in the database. So this whole diagram depicts the scenario of new transaction as a part of block generation, block addition or rejection by the validators, and then their replication to the peer systems. This slide depicts the blockchain innovations. Bitcoin, that was first implementation of blockchain application in 2008, and blockchain as application was the second innovation. First was your cryptocurrency, and then second was as application was for the second blockchain innovation. And third was the most smart contract embedded in a blockchain 2.0 system with introduction to Ethereum. Ethereum helped taking the and bringing the smart contract system in the blockchain 2.0 system that helped computer programs directly built into the blockchain that allowed financial instruments. Now, developers and users were able to write logics in smart contracts that were helping them to regulate financial transactions and use blockchain as financial instrument. The fourth critical innovation was proof of stake. Current generation is secured by proof of work, the new system replacing them with complex financial instruments for similar high degree of security is proof of stake. Now, blockchain and distributed ledger technology, how they differ from traditional databases. Let's understand more about blockchain and see how it differs from traditional databases. Later we will discuss about the distributed ledger technology as well. This whole table compares blockchain versus traditional databases in terms of various properties or you can say areas or features. First is data ownership. Maintained through in blockchain, it is maintained through cryptographic key pairs and native cryptographic algorithms using public and private key pairs for encryption and decryption the information sent over the network. Legacy databases, how it happens? It happens via central authority, the database administrator, who is responsible for maintaining the data and access controls apart from other required activities. Privacy and security. It is again maintained in blockchain using cryptographic authentication. Private and public keys are used to identify the sender, the initiator of the transaction, and other properties of the data block. In legacy database, it is again configuring each row based on enforcement from a central authority. Your again database administrator is responsible for maintaining the privacy and security of the databases. Access control. Inherently identical for all permission nodes and maintained through given permissions in permission blockchains. In databases, it is actually centrally administered and applied by the database administrator again. Trust. Native via immutable records. So this is coming as part of the blockchain concept only. Since records are immutable, you can trust the blockchain that no alteration or change to data will happen without valid transactions. In legacy databases, you had to trust on central authority only for your database integrity, and security. Now comes data quality. Immutable records in blockchain with automatic conflict resolution through consensus for transaction. Blockchain, the logics are written in a way that the records become immutable, and while registering new blocks, the conflicts are resolved using consensus between participating nodes. In databases, complex conflict resolution process requires manual intervention, sometimes to resolve the conflict and maintain data quality. Database validity. In blockchain, it is continuous. All databases ledgers remain in sync and store same copy of information and always update it for each and every new block added. In legacy databases, provided for single instance in time. Data propagation. Quick propagation across all network nodes and every time a new block added and a new transaction initiated. In legacy databases, it is managed through multi-version currency control and through custom synchronization. That is again done by database administrators. Enforcing data transformation built into data layer logic only. So your data layer logic itself keeps this data transformation handy. In legacy databases, there's no provision for enforcing data transformation. Currency and synchronization. In blockchain, we already seen that consensus always commits only a one block, new block at a time, and hence maintains identical copies of data. In databases, it involves complex checking between central DB and users DB to ensure agreement. Reliability and availability. Peer-to-peer networking for distributed data replication across all nodes. Because peers are and nodes are connected in network forms, so reliability and availability is already maintained through replication between all ledgers at the same time of new block generation. In legacy databases, there is always a chance of single point of failure, and availability is again always a question. Stored procedures are smart contracts, while in database not available. Transaction creation is available to all permission parties. They can start transaction and help generating the new nodes. In legacy database again maintained via central authority. Fraudulent or malicious changes. Immutability through reliance on previous block helps ensuring there is no alteration to data or deletion of data happens inside the blockchain network. In legacy databases, not available where current keys and check constraints remain insufficient. So it's again a question in current databases that fraudulent or malicious changes cannot happen. There is always a chance and risk of changing the existing data. So that was a brief introduction about differences between blockchain and legacy databases. So now we will see what distributed ledger technology is and how it helps overcoming the problem of traditional databases, legacy databases. People think of blockchain technology and distributed ledger technology as one and the same. Interestingly enough, that is not the case. Let me show you the difference. These are the properties of digital ledger technology. Programmable, distributed. When we say distributed, all network participants have a full copy of the ledger for full transparency. Anonymous. The identity of participant is either pseudonymous or anonymous. Direct identities are never used in blockchain. Timestamp. Transaction timestamp is recorded in every block. Unanimous. All network participants agree to the validity of each of the records. Whenever a new block is generated, each validator participates to validate the block and then help to add into the blockchain. Programmable. As we already discussed, blockchain is programmable. You can write your own logic and conditions to be met to help serving your business logic using the blockchain platform. Secure. All records are individually encrypted. Immutable. Any validated records are irreversible and cannot be changed. In short, all blockchains are distributed ledgers, but not all distributed ledgers are blockchain. Means blockchain is a subset of distributed ledgers. Hope it clarifies the difference between blockchain and distributed ledgers. So this pictorial presentation represents the various uses of blockchain. This is globally distributed with almost zero barrier to transacting goods and services. It provides online payments and digital currencies use cases, and that was the first use case in form of a Bitcoin. A range of industry use cases across banking, automotive, insurance, healthcare, life science, manufacturing, retail, and telecom are available, possible, and under research. Highly secure cryptographic implementation makes it really secure. All transactions being encrypted and decrypted using public key pair provides additional security on all the data being transmitted. The blockchain changes the game in IoT, Internet of Things. Blockchain has emerged as a game changer in the other widely being growing area, that is Internet of Things, and really make it feasible to derive the application on basis of Internet of Things when used with blockchain. Peer-to-peer with no central authority. That constitutes a major benefit of blockchain, removing intermediate nodes or mediators from the network. Completely transparent and auditability. You can come anytime, traverse through the blockchain, and you will be able to find each and every detail in the form of consecutive blocks, recorded transactions that are really coherent and related to each other, and easily show you that there is no alteration or change happened to the recorded data in the database. This slide depicts comparison between popular blockchain frameworks. We are comparing here Ethereum, Hyperledger Fabric, and R3 Corda. Before moving with the comparison, I must tell you about these three terms. These are three kind of blockchain platforms available in the market that differ in characteristics but inherit all the properties of blockchain that make them part of secure blockchain technology. Description of platform. The first characteristics where Ethereum uses generic blockchain platform, Hyperledger Fabric uses modular blockchain platform, and R3 Corda uses a specialized distributed ledger platform for financial industry. Governance. Ethereum is owned by Ethereum developers, while Hyperledger Fabric is being managed by Linux Foundation and R3 Corda is being managed by R3. Mode of operation. Permissionless, public or private. So Ethereum can be permissionless, public or private, means restriction or restrictionless, both. While Hyperledger Fabric is permission and private only. This is meant for enterprise uses and hence provide more security by restricting the access. R3 Coda is again permission and private, having more secure implementation. Consensus. Mining of new blocks is based on proof of work in Ethereum and at ledger level. Broad understanding of consensus that allows multiple approaches. In Hyperledger Fabric, you can use PBFT, proof of work, proof of time, and other approaches as per your requirement and the way your resources allow. Then consensus occurs at transaction level in Hyperledger Fabric. In R3 Coda, specific understanding of consensus that denote required to design and the consensus is given on transaction level. Smart contracts. Smart contract codes are written in programming language mostly called Java called Solidity that is similar to JavaScript. In Hyperledger Fabric, smart contract code example Go and Java are used to write the programs for smart contracts. For R3 Coda, wherever Kotlin and Java languages are used, and smart legal contract uses legal prose. Currency produced by the Ethereum is Ether and tokens via smart contract. In Hyperledger Fabric, there is no currency produced, while currency and tokens are generated via chain code. There is no inherent currency in Hyperledger Fabric. You can design the situations and tokens as per your business logic in Hyperledger Fabric. R3 Coda has no currency, and this is basically used for financial industry. This pictorial diagram represents difference between centralized and distributed ledgers. The first picture, you can see that in centralized ledger, all the clearing of funds is being done by central authority, while in distributed ledger, fund clearance is being done by each node and they need to agree on the transactions. Blockchain structure. Since we have learned enough about blockchain theoretically, we should be learning on blockchain structure now. How a blockchain structure is derived and designed. Let's see what goes inside the block of Bitcoin blockchain. What component constitutes the block of Bitcoin or any other blockchain? We'll try to understand using Bitcoin example. A Bitcoin blockchain structure is consisting of three components: header, Merkle, and list of records. When we say header contains version info, nonce, previous block ID, and timestamp, while Merkle is a hash built from blocks transaction identifier. What is Merkle? We will be looking into detail in coming slides. List of records. Identification hashes that was included into blocks Merkle tree. So your Merkle is built from blocks transaction identifiers and those transactions list of record is contained in the transaction ID list. Diagram also depicts it clearly. The first portion is header, which contains version number, nonce, previous block hash, timestamp. Middle one has Merkle, that is the hash of blocks, IDs, transaction IDs, while the last block section says Merkle tree hash of all transactions that is present in the middle block is contained from this list of transactions. So you could see that these various properties help to identify the relative block in the blockchain, and no one can touch and alter the sequence of blocks or data inside the blocks. The structure of the Bitcoin block header. Continuation of the same, it consists of three sets of block metadata, reference to a previous block hash, the difficulty, timestamp and nonce, and Merkle root. Below is the table that depicts the size of each item inside the blockchain header. Your version is 4 bytes. That could be a version number to track software protocol upgrades, 32 bytes, previous hash block, that is could be of 32 bytes length, a reference to the hash of the previous block in the chain. This is 32 bytes, Merkle root, a hash of the root of the Merkle tree of this block, and 4 bytes again timestamp takes, and that is the creation time of the block. Then 4 bytes difficulty target, the proof of work algorithm difficulty target of the block, that is set by these 4 bytes. Then nonce. Nonce is the value we already discussed. That was the winning number from proof of while solving the proof of work puzzle by the validators. Block identifiers, block headers hash, and height. Your block header hash is the primary identifier of a block is its cryptographic hash. So any block, newly created block, has its cryptographic hash as the primary identifier of the block. Then a digital fingerprint made by hashing the block header twice results in 32-byte hash. The block hash identifies a block uniquely. These are the properties of block header hash. The block hash is not included inside the block's data structure also. Block site. It is the position of the block in the blockchain. So every blockchain, first ever block, the genesis block starts from 0 position. Each block added on the top has one position higher in the blockchain. That means n plus 1. If the current blockchain length was n, newly blockchain length will be n plus 1. Each block added on top has one position higher in the blockchain. So it is also not a part of blockchain's data structure. Each node dynamically identifies the blockchain's height in the blockchain. So blockchain's height is again a part of every block's field. So this was few items about your blockchain data structure. Merkle trees are important part of blockchain data structure that we have already seen here in previous slides. Like Merkle tree comes in the middle of the blockchain data structure, block structure, which contains hash of all the blocks transaction identifier listed in the last section of the block structure. How it is calculated? Now, Merkle tree, also known as binary hash tree, and a data structure used for summarizing and verifying the integrity of large sets of data. It contains cryptographic hashes displayed upside down with the root at the top and the leaf at the bottom. From the figure you can see all these points listed here can be compared with the present diagram. A block of one or more new record is collected and such records are then hashed, and the hashes are then paired, hashed, paired again and hashed again until a single hash remains. So what your Merkle tree does and how the values are calculated. If you see the diagram, you could see these are L1, L2, L3 and L4. These all are transaction data blocks. So while calculating the Merkle tree top hash, you pick transaction in pair and then calculate the hash of each transaction, each data block's ID, and which gives you these intermediate blocks. Once these hashes are calculated, they are hashed again and one single hash value is populated against these two items. Iteratively, these two blocks of hashes hashed again to form a root of Merkle tree. So this is how the hash value of Merkle tree calculated. L1, L2 transaction, then L3, L4 used in pair to calculate hash of L1, hash of L2, then hash of L1 and L2 are combined and hashed again to produce a combined value and root of the Merkle tree. So the single hash at the top of the root is called Merkle root of a Merkle tree. What are the advantages of Merkle tree? Why these are integrated part of any blockchain data structure. Merkle tree proofs and management requires only a very small and terse amount of information to be transmitted across a network. They do not create any overhead, but they in return help keeping your blocks data secure, and labeled hashes help to avoid any alteration to a database by or during any time of transition. A tree constructed by hashing pair data, the leaves, then pairing and hashing the result until a single hash remains the Merkle root. In Bitcoin, the leaves are almost always transactions from a single block. Merkle tree requires little memory and disk space, and proof of are computationally easy and fast. This is how your Merkle tree advantage or helps you keeping your blocks secure and easily validated. So this slide depicts the calculation of Merkle tree root from transactions. Suppose we have even number of transactions 0 to 7, and now you are trying to add next block 7. So we need to see how the structure of this blockchain and Merkle tree value will be calculated. The Merkle tree consists of even number of transactions, 1 A, B, C, D, 4 transactions. Then from these transactions you get transaction value of A, B, C and D. These transaction values are hashed, combined, and hashed for both AB and CD in pairs. Then we get two values that are hashed again and combined with the hash of block 6, that is the previous block, and value of ABCD hash, the timestamp of creation plus nonce. And this way the structure of block 7, the header of block 7 is created. This clarifies how your blockchain header is calculated for new blocks. What if we have odd number of transactions? Let's suppose there are odd number of transactions in a block. In this case, the last transaction is hashed with itself. What does this mean? It means if we depict the diagram here, we have odd number of transactions and the transactions number 6 do not have any pair to create hash for. In this case, this number is hashed with himself and the result generates the number itself, the block hash itself. This way, if you have odd number of transactions, the Merkle tree is calculated. So this diagram actually depicts the transaction root or Merkle root inside a existing blockchain. So this can now be easily understood that data 1, data 2, data 3 and data 4 are calculated, hashed and then hashed again to retrieve a value of Merkle root. Blockchain ecosystem. What this term stands for. That means let's have a look with what are the components required to implement a blockchain. To implement a blockchain, you need distributed ledgers, node application, consensus algorithm. So these three are the main components of blockchain, and in order to build any blockchain ecosystem, you require these three components. Cryptographic and consensus algorithms. We know that cryptographic and consensus algorithm are key constituents of any blockchain. So we learn to see what methods we can use to write our or can use with our cryptographic algorithms. There are three algorithms available majorly used with blockchain. Triple disk uses three individual keys with 56 bits each. The total in this way, the total key length adds up to 168 bits. Second, RSA is public key encryption algorithm and the standard for encrypting the data sent over the internet. RSA is again most popular cryptographic algorithm that is used to perform the cryptographic functions. Third one is Blowfish. Known for its speed and effectiveness, symmetric cipher splits and messages into blocks of 64 bits and encrypts them individually. So, Blowfish again uses symmetric cipher suits and it is more in speed in order to encrypt and decrypt the messages and into blocks of 64 bits and then encrypt them individually. RSA algorithm, because this is widely used encryption algorithm in a blockchain technology, so we will be depicting its functionality from the given diagram. How it works. When a sender wants to initiate a transaction, he uses RSS in cipher and its private encryption key to produce a enciphered data, or you can say encrypted data, that is sent over communication channel as ciphertext. Once received at the target receiver end, this RSA cipher is used to decipher the information from the ciphertext and to get the plain text out of it. This is whole being done using the decryption key or private key of the recipient. How RSA works? So we now have a public key and private key and a method of encrypting and decrypting using those keys. Let's see example to clear details. There are different approaches used in attacking the RSA algorithm. Brute force, it involves all possible secret keys in order to decrypt the information encrypted by RSA. Mathematical attacks are also possible ways. In mathematical attack, we are using different techniques which is similar in effort to the factor the product of two primes. So these are the two kind of ways approaches used for attacking the RSA algorithm in order to decrypt the information. Consensus algorithms. What consensus algorithms are used and typically used? The consensus provides the technical infrastructure layer for blockchain. This makes it one of the most critical components when assessing real-world use cases. Consensus are programmable, so you can write them according to your business need and your use case scenarios. Consensus is key because without a central authority, the participants have to agree on the rules and have to and know how to apply them. Consensus does two below things. It ensures that the next block in a blockchain is the one and only version of the truth. There is no faulty data or block available and should be present in the block. That is ensured by this consensus algorithm. Second, it keeps powerful advisories from derailing the system. Means there's no authority, central authority, controlling the system of blockchain. That is again ensured by consensus algorithms. So in this way, we can understand that consensus is the heart of the blockchain. So from the picture, you can see and understand that in multi-parties transaction, any party can initiate the transaction. The transaction are recorded in order to network block and presented. Then the block is broadcast to the network and validated via the consensus mechanism. The network of nodes validates, verifies via consensus and confirm. The consensus is recorded and then provides the basis of the trust mechanism. Once verified, published, the transaction becomes a part of the new block for the ledger, and the new block is then added to the existing blockchain and transaction is complete this way. So this is whole cycle of doing consensus and writing a new block to the system. What is needed for the consensus? The basic concept acceptance of laws, rules and norms to decide a transaction on which all nodes should agree and follow the rules. The common acceptance of industry and institution that applies these laws and rules. This is very important. When you are writing a consensus, you have to abide by the rules of that institution for which you are adding the consensus and building the blockchain. If it is not done so, though, then the consensus will not produce a result that is expected by the organization it is implemented for. Now, we had already discussed what is needed for consensus. So, the basic acceptance of laws, rules, and norms to decide a transaction should be part of your consensus mechanism. And similarly, the common acceptance of industry and institution that applies these laws and rules should also be considered while designing and developing the rules and algorithms for writing consensus mechanisms. So, in short, in layman term, if I explain, so consensus should include your all business logic, your all business logics, conditions, and all scenarios during any financial transaction or any business that your organization is doing and for which you are developing the blockchain consensus mechanism. So while designing consensus mechanism, what should be basic parameters and how these should be handled, that we will be learning in this slide. First parameter should be your decentralized mechanism. So as we know, while working on consensus, we are dealing with decentralized ledger, say blockchain. So a single central authority must not provide any decision finality. It should be designed and should be decided from consensus itself. Second parameter should be your quorum architecture. Nodes exchange messages in predefined mechanism, which may include stages or tiers. So what does this mean? This means every node that is transacting in the blockchain should follow certain predefined steps, and any node deviating from this should be considered as a bad node and removed from the transaction. Third, validation. It provides means to verify the participating identities, including your validators as well. So suppose your transaction is started from a peer node A and he is trying to send some bitcoins to recipient or peer node B. So The consensus mechanism should be written in a way that it is able to identify the identity of participants participating in sender and receiver mechanism of Bitcoin and should validate having the information from the transaction itself. Without validation, none of the node or transaction will be recorded in the blockchain. Fourth parameter that should be considered by developing your consensus mechanism is integrity. So as you all know, it enforces the authentication of the transaction, integrity and validation. So any transaction should be authenticated from the consensus nodes or validator nodes, and then only they should be recorded in the blockchain. Now, fifth parameter would be non-cancellation. This provides means to verify that the supposed sender really sent the message. And this we already learned. This could be done using the private public key pair. The validator node use public key of the sender in order to validate the identity by decrypting the message and using hash mechanisms. Sixth parameter is confidentiality. So your consensus mechanism should provide means to verify that the supposed sender really sent the message and whatever he sent is not changed and not visible to anyone. So the information shared inside the packet or transaction should be kept confidential and should not be visible to any other member inside the network. Your consensus mechanism should also take care of fault endurance. So the network operator should operate the network efficiently and quickly even some node fails or are slow. So what this means is even if your part of network of blockchain is faulty or slow, then the network operation should complete in quick and timely manner. There should not be any delay or loss of transactions. And the last parameter that should be considered while designing your consensus mechanism is fulfillment. That means it considers throughput, liveness, and latency. All should be. That means your consensus mechanism should not be complicated enough or should not be designed in a manner that create unnecessary slowness, complexity, and latency while performing the validations inside the blockchain network. Before moving further, we should understand how consensus mechanism came into picture. What was the history behind it? So the logic came from Byzantine general problem, where Byzantine army has completely encircled the city. The army has many divisions, and each division has a general. This story we have already heard. Some of you have already heard many times while learning some mathematical problems or while learning your algorithms. The same idea has been derived from again Byzantine general problem here in order to write your consensus mechanisms. So the actual story was like the army has many divisions and each division has a general when they encircled the Byzantine city, and the generals were dependent on communicating between each other, between their lieutenants within their division by exchanging the messages. So they were not able to communicate directly. The lieutenants were helping within their division to pass the messages to their generals, and this is how they were communicating. All the generals or commanders have to agree upon one of the two plans of action. That means exact time to attack all at once, or if faced by fierce resistance, then the time to retreat all at once. So the army cannot hold on forever. If the attack or retreat is without full strength, then it means only one thing: unacceptable, brutal defeat. So everyone had to be trustful and work in coordinated manner. When it was time to attack, they should be attacking with their full force and full strength without deviating from the rule decided, and if there was time to hold back, then they also should be doing it full strength. So complete agreement was required and complete action was required from whole force. So results: if no in order to succeed, two-thirds of the generals needed to be loyal to the army. If the amount goes less, that means if more than one-third generals are in disagreement, then there were likely chances to get defeated or failed during the war. So what was the solution to this problem? How they had to decide that their generals are trustful and trustworthy. They are not going to be deviate from the rules decided in order to get succeeded during the war. The practical Byzantine fault tolerance algorithm (PBFT), which is used to establish consensus in blockchain systems, is only one of those potential solutions that were expected to help the generals and the army to get in more than two-thirds of consensus during any attack and get success during the any kind of attack they were moving upon. What was PBFT? So the solution came in 1999 when Miguel Castro and Barbara Liskov introduced a PBFT algorithm. PBFT can process an enormous number of direct peer-to-peer messages with minimal latency. How it works? asynchronous distributed system where nodes are connected by a network. Byzantine failure model was faulty nodes behave arbitrarily. Independent node failures may happen in that case. So, cryptographic techniques to prevent spoofing and replace and to detect corrupted messages were also enforced in this algorithm, and there was a plan to have a very strong advisory in order to get two-third or more than two-third of consensus and avoiding fault and misbehavior of nodes, or you can say generals, during the message communication. This method of establishing consensus required less effort than other methods. What was actually happening? Each node, the whole piece of army, was arranged in form of a connected network. They were the peers nodes were connected in a manner like they were not connected to only one of the node. Nodes were interconnected with each other. So if some nodes start misbehaving or arbitrarily, then other nodes were able to pass the message to the connected nodes. So in this way, the generals were sure that the information they are getting is authentic and all the nodes are in sync. So this way of transmission was really fast, reliable, and was helping to attain a significant amount of consensus in less amount of time. So the propagation was happening through connected nodes. Now, the other consensus mechanism that we can use inside blockchain is proof of stake. Proof of stake, like proof of work, is a category of consensus algorithm for public blockchains that depend on a validator's economic stake in the network. Newer kind of a consensus algorithm, it was introduced considering the drawbacks of proof of work where energy consumption and time consumption was very high. And in order to succeed and become a winning block, the participating validators has to invest huge amount of energy as part of solving complicated problems. It was pioneered by Peercoin in 2011. Now, due to this, many versions exist for this proof of stake consensus mechanism, out of which some are NXT, Tendermint, Flying Fox, etc. Your chance of being picked to create the next block depends on the fraction of coins in the system you own. As the name suggests, the more coin you have, more chance of getting a chance to create a new block will be given to you. So this mechanism helps deciding the winner node on the base of a stake he already has. And in this way, the nodes do not need to solve complex problem in order to win the situation and create the new blocks. And this really helps saving the energy and resources during any new block creation, which is a frequent mechanism, a frequent step taken in any blockchain. A participant with nothing to lose has no reason not to behave badly. This is called nothing at stake problem. That means since it is really transparent that the node with required amount of stack or higher amount of stack will be selected. So in this way, since none of the nodes required to solve complex problems and get rewarded, so they cannot cheat the system by misbehaving and try creating the false results or false solutions to the given problems. The validators or winners are clearly picked from the available stake, and in this way they can help to creating the new blocks. So as of now, since we already know what is proof of work and proof of stake, so let's have a glimpse like how they differs in terms of each other. In proof of work, the probability of mining a block depends on the amount of work a miner does. That means he needs to find a solution for the given problem, and all the competing nodes are working to solve the same problem and find a particular number x or any number that is the end result of the solution. Since this requires solving more complex problems, it requires more energy than proof of stake. And one example is mining, which uses computer cycle time to validate new transactions. So mining of new blocks, as we already discussed, is using computer cycle time to validate new transactions, and every transaction new mining is generated. Sorry, every block through new mining is generated every 10 minutes in Bitcoin. That we already seen. So stakeholders in proof of stake validate new blocks by utilizing their share of coins on the network. So the validators nodes actually work on the share of the coins they have in the network, and that is called stake in proof of stake consensus mechanism. The first example of proof of stake was Peercoin. A user would need to own a majority of all coins in order to attack the network. What this means is this mechanism helps any node behaving badly and retrieving them, and because they need to have majority of coins available in the Bitcoin or blockchain network in order to attack the network. Since at a single point of time, none of the node can have the majority of coins to alone attack the network and create their own nodes. They will not be able to cheat the system or hack the system at any moment of time. So this way we can see the proof of stake, again a very good algorithm or consensus mechanism that can utilize less amount of energy than your proof of work and still able to make system cheat proof and avoid hacking of the system from the bad nodes inside the system. Till now, we have learned about various consensus mechanisms that are helping validator nodes in order to become winner and introduce new blocks inside the blockchain network. There is another kind of consensus algorithm was introduced by Intel basis on the analysis on the existing block proof of work and other mechanisms that were really time consuming and resource consuming and resulting loss of energy as part of new coins generated inside the bitcoins. So what proof of elapsed time does, how it is having advantages over existing consensus mechanisms. So proof of elapsed time was introduced by Intel and developed its own alternative consensus protocol called proof of elapsed time, which was based on waiting time or idle time of validator nodes. Proof of elapsed time, a Nakamoto-style consensus algorithm that is designed to be production-grade protocol capable of supporting large network populations. It means this was able to give fair chance to all validator nodes in order to create new blocks inside the blockchain in large network populations. POET relies on secure instruction execution to achieve the scaling benefits of a Nakamoto-style consensus algorithm without the power consumption drawbacks of the proof of work algorithm. As we all know that proof of work algorithm requires to solve huge complex problems in order to become winner. That was requiring good hardware configuration and huge amount of energy to be spent in order to find solution of the given problem. Basis on this, Intel analyzed that this consensus algorithm is having its own drawbacks and requires a lot of energy to be wasted. So they thought of giving time to all the nodes. For that time, they can sit idle and wait for their term in order to get the chance to create new blocks inside the blockchain network. So that's why it is called proof of elapsed time algorithm, because every node after creation of new block was given an idle time for which they can stay in sleep mode, and then when their time expires, their elapsed time expires, they are given a chance to create new blocks and fair chances given to every block inside the every validator node inside the blockchain. POET example is used by Hyperledger Sawtooth, which is again Intel blockchain network. POET simulator, which provides POET style consensus on any type of hardware including a virtualized cloud environment. So this consensus algorithm can be used in any including virtualized cloud environment as well. So what are the advantages? Why we should be using POET over proof of work and other existing PBFT or other consensus mechanisms? For the purpose of achieving distributed consensus efficiently, a good lottery function POET has several characteristics. Fairness. It gives the function should distribute leader election across the broadest possible population of participants. Means all participants, validator nodes participating inside the validation and creation of new block should be given fair chance and equal chance in order to create a new block inside the blockchain. And that is being achieved by proof of elapsed time algorithm. Second was investment. The cost of controlling the leader election process should be proportional to the value gained from it. That means any validator node should not be investing too much resources, too much cost in order to gain a little reward from the system against new block generation. Verification. It should be relatively simple for all the participants to verify that the leader was legitimately selected. Every node should be given a fair chance, and that is what this POET algorithm ensures and helps giving every node a fair chance in order to create new block inside the blockchain network. So this was all about consensus algorithms that we discussed. There are many more existing inside the current blockchain world, and every consensus algorithm is picked depending on the requirement and amount of resources available for creation of blockchain. Definitely, the low cost and efficient algorithm will be picked and used against other available algorithms while selecting any consensus mechanism. Moving to types of blockchain. So based on the scenarios and based on the categorization, blockchains are divided into multiple categories and differentiation is based on the current scenarios that are being used. Blockchains can be categorized into permissionless or permission blockchains. Simultaneously, they can also be categorized as public and private blockchain. Let's see how this is being done. Blockchain types. Public blockchain. A blockchain that is public is a decentralized, distributed and public digital ledger that is used to record transactions across many computers so that the record cannot be altered retroactively without the alteration of all subsequent blocks and the collision of the network. Example: Bitcoin, Ethereum, Dash, Factom. Just to explain, blockchain, the public blockchain are accessible to everyone. Anyone from public can come, join the network and start doing the transactions. They do not have restrictions in order to create new blocks and in order to participate in the blockchain network. Obviously, the consensus mechanism will be there in order to validate the newly created blocks, and before committing them, they should be validated. Second type is private blockchain. As the name suggests, these are private blockchain network that requires an invitation and must be validated by either the network starter or by a set of rules put in the place by the network starter. So they have well organized algorithms written that whenever a new joiners come to the blockchain network, they are validated, they give certain access that is again restricted, and they need to perform their transaction accordingly. Examples: multi-chain and block stack. These are certain examples of private blockchain networks. The third type also exists that has more restrictions than these two, that is called consortium. Controlled by a consortium of members, only predefined set of nodes have access to write and read the data of block. Example: Ripple, R3 and Hyperledger 1.0. So these are really well suited for organizations that want to control their blockchain network and perform transactions in their own way. Second type of categorization of blockchain is permission and permissionless blockchains. Properly permissioned blockchain network differs from unpermissioned blockchain network solely based on the access control layer built into blockchain nodes. So, as the name suggests, permissioned blockchains are secure and give limited permissions to the miners and the joining peers inside the nodes. Every peer participating inside the blockchain network in permission blockchain is given certain amount of permissions only in order to perform certain actions. While in unpermissioned blockchains, peer nodes are free to do any kind of transactions without having any restriction and generate new blocks. Mind it that the consensus mechanism will always be there inside blockchain for validation and creation of new blocks, that is mining. So in permissionless, since the network is open, anyone can participate and contribute in the consensus, hence it is called permissionless blockchain. Versus the permission blockchain, where that restricts the actor who can contribute to the consensus of the system state, hence this is called permission. You have any actor need to behave within the permission assigned to it, and he can result in actions according to that only. So based on these, public and private blockchains can be differentiated and categorized or bifurcated into as per the below chart and against below properties. Like if we talk about access, then public blockchains are always available publicly, and anyone from public peer can read and write the data inside the distributed ledgers. In private, only nodes having access can write or read to the distributed ledgers. Speed. Since in public networks, multiple nodes can join at any time, and the number of nodes inside the public blockchain network are always high because of its openness, so transaction amount is also again high, and in turn this lowers the performance and efficiency of the blockchain, the overall blockchain network. Against to this, private blockchain networks are faster, and because they have low number of nodes and peers participating inside the blockchain networks. Security. If we talk about security, private blockchains, security is provided by proof of work and proof of stake that we have already discussed, while in private, it is provided by the pre-approved participants. Next comes identity. So in public blockchain, rather using direct identity, anonymous or pseudonymous identities are used. We have already discussed what anonymous and pseudonymous identities are. Anonymous identities are where you will never be identifying who is the sender, who is the participant participating in the transactions. While in pseudo identities are used, rather using direct identities, like your employee ID is your pseudo identity, or your candidate ID, voter ID, these are all pseudo identities using which someone identifies you in public blockchain networks. Despite of this, in private blockchains, pre-approved identities are used. Any participant that is participating or created inside private blockchain is given an unique identity, and that is already approved and used in all transactions initiated by him and to validate him by the validators. Assets. Native assets are used in public blocks and in private blockchains. Any asset can be used as native asset in order to store the transactions. So this was all comparison about between public and private blockchains. So based on the four criteria, we divided the blockchains into public, private, and permissionless blockchains. These can be again summed up in order to create four categories of blockchains, that is permissionless public, permissionless private, and permission private. Out of which permissionless public blockchain is very much open and most accessible to the any member or any outsiders that can participate inside the blockchain and do start transactions. Anyone can download the protocol and validate the transaction and create new blocks. Example of this kind of blockchains are Bitcoin, Ethereum, and Zcash. While in permission blockchain, permissions are included for the peers that are participating in the network, and it works on the proof of stake consensus algorithm. Ethereum after Casper is an example of permission blockchain, and anyone who meets the certain predefined criteria can only download the protocol and validate transactions. That means you have to give explicit permission to the members that are contesting or participating in blockchain creation. Then comes permissionless private. That has certain restrictions, but there is no specific permission granted. All the nodes are given public access and that are private to the organization itself. So in short, we can say all nodes that are part of the blockchain are interacting inside the private blockchain and all have all the permissions required to initiate and transact inside the blockchain. Then comes most secure blockchain, that is permission private blockchain. This is private to an organization, consortium, and has different permissions according to which all actors interact within the blockchain network. PBA and IPDB are example of permissionless blockchain private blockchain network, and PBFT and multi-signature are example of permission private blockchain network. So if we see in this diagram, so the public to private and the entities decrease from top to bottom, and if we talk about permission, then it goes again from validators to from permission to permissionless blockchains. Sidechains. There exists another term inside blockchain platforms that is called sidechains. What are these sidechains? Sidechains are separate blockchains which is connected to other blockchains through the use of two-way peg, which allow transfer of digital coins or assets between blockchains at a fixed or otherwise deterministic exchange rate. If you can see from the figure, various sidechains are existing along main blockchain and giving two-directional arrow that allows transfer of bitcoins or digital coins or tokens between these sidechains and within main blockchain. These blockchains or sidechains, you can say, serve various purposes. Like this one sidechain can be used for beta releases before making it main branch of existing blockchain. Beta releases can be used to test the release before making it part of main release of blockchain. Similarly, there could exist sidechains of sidechains even, and these can serve different purposes. Even this can be used as microservices like micropayments. This can be used for R&D purposes, research purposes, and serving various other needs that an organization need. Sidechain extensions can be done in following manners. They can be used as native asset issuance. They can be used as smart contracts. They can be used as real-world property registries, and they can be used to secure handles. Sidechains can have other sidechains for things like micropayments. They allow for experimentation, pre-release versions of future sidechains, or even a beta version of Bitcoin itself. So, what all the advantages are that sidechain offers? Sidechains enhances blockchain performance and privacy protections. How they do this? When you have a different requirement, you want to test any new blockchain release. If you have any other service integration with, you can do it using sidechain without interrupting the existing main blockchain network. So your existing blockchain can keep serving the request the way it is doing as of now, and your new sidechains can be used to serve your special needs and special requirements that may not be needed as part of the main blockchain. Second, what they offer is sidechaining is any mechanism that allows tokens from one blockchain to be securely used within a complete separate blockchain, but still moved back to the original chain if necessary. Your sidechains are part of your main blockchain. They allow a point where bitcoins or other tokens can flow from main blockchain to sidechains and from sidechains to blockchain, vice versa. So, existing blockchain tokens can be used and utilized whenever required in the new transaction in sidechain as well. Sidechains can have other sidechains for also as micropayment, as we have seen in the above diagram. So These are the benefits of sidechains that offer when existing with the main blockchain. Transfer of assets inside sidechains. How it happens. Let's take an example of root raw stock in order to transfer assets from one chain to another. So how it happens? The step one, a user on the parent first has to send their coin to a special output address that is of root stock address, and then coin will consequently become locked and unspendable. So the moment main blockchain start sharing his blockchain, that amount of asset is locked inside the main blockchain and becomes unusable for that amount of time inside the network. So it will not be shown in the main balance of the wallet of that node. Then the next step becomes, after the transaction completes, the SPV then confirms it across the chains. So what does happen? When the transaction is completed, the blockchain node is freed up that amount of transaction and start reflecting in the network as its main available balance. So this is all happening by using the transaction and the coins available in the main blockchain, and that was used for transaction inside the other sidechain network. After waiting out a contest period, which is just a secondary method to help preventing double spending, the equivalent amount will be credited and spendable on the sidechain and vice versa once the transaction is completed. So when SPV confirms, where SPV stands for simple payment verification across the chains, then transaction is considered complete and the amount is again returned back to the and start showing in the node's wallet. Sidechains have their own miners to help protect them from nefarious actors and attack against the network. So, in short, we can say that sidechains also are small blockchains that have their own miners and ensure the integrity and validity and authenticity of any transaction coming across in the network. So, what are the platforms for implementing blockchain? Nowadays, since blockchain has evolved a lot in last one decade, there are many developers, organizations, investors, and ideas generators have evolved with various kind of blockchain platforms. So nowadays there exists multiple blockchain with multiple facilities, multiple advantages, and multiple features, out of which we will be discussing about few that constitute important area inside blockchain terminology. The first one is Ethereum. We all might have heard about term Ethereum. It is a public permissionless blockchain, a blockchain platform that lets anyone build and use decentralized applications that run on a blockchain technology. Like Bitcoin, no one controls or owns Ethereum. It is a public permissionless blockchain network where everyone can participate and transact and earn token or currency. Then comes multi-chain. This is again a blockchain platform for the creation and deployment of private blockchains, permissioned blockchains. So it can be used either within or between organizations as well. So this is permission. So this is permission and it requires permission in order to transact and participate in the existing blockchain multi-chain network. Hydra chain, a joint developed effort of Brainbot Technologies and the Ethereum project. It supports the creation of scalable blockchain based applications. Then comes Hyperledger. This is again becoming very much famous in blockchain technologies. It is an open source collaborative effort created to advance cross industry blockchain technologies. It is supported by Intel and open source Linux Foundation. Then OpenChain. OpenChain is again a blockchain platform that is well suited for organizations wishing to issue and manage digital assets. It takes a different approach than the standard Bitcoin approach on implementing blockchain. Then IBM Bluemix. Being a giant player, IBM also allows and have their own blockchain network and platform that is on IBM Bluemix, built on top of Hyperledger project, and it offers additional security and infrastructure facilities for enterprises. So IBM are preparing blockchain in such a manner that they are enterprise ready and can be directly used by enterprises and financial or other organization to start and migrate their existing applications to blockchain network in order to facilitate and utilize the features and benefits provided by blockchain. There is another kind of blockchain network exists that is called chain, yet another and well suited for financial applications based on chain core, which is an enterprise software product. Then IOTA is another blockchain that is a revolutionary new blockless distributed ledger which is scalable, lightweight, and for the first time ever makes it possible to transfer values without any fees. If we see, the above blockchain platforms take some amount of fees in one form or other, while IOTA helps, that is again a blockless distributed ledger and do not take any fees for doing transaction over blockchain network. There are various more. BigchainDB, an open source system that starts with a big data distributed database and then adds blockchain characteristics, decentralized control, immutability, and the transfer of digital assets. Then comes Corda. It is again a digital ledger platform which pluggable consensus. So multiple consensus can be used here, plugged with the blockchain and utilized, and simply forms a different kind of blockchain with flexibility of adding pluggable consensus. You can anytime change the consensus algorithm from proof of work to proof of stake, from PBFT, from POET. So it provides various options of using multiple consensus algorithms. Quorum, an open source digital ledger and smart contract platform based on Ethereum, that is customized Ethereum platform using distributed ledger and smart contract. Stellar, an open source distributed payment infrastructure that provides RESTful HTTP API servers which connect to Stellar Core, the backbone of the Stellar network, and help you giving a blockchain network where you can utilize and do your transactions related to your business need. So, in this session, we will be discussing the third topic of our course agenda, that is Bitcoin and blockchain. Everyone knows who has knowledge about the blockchain knows that 2008 was the year when blockchain was invented by a Japanese scientist. So that time, Bitcoin was the first application created over blockchain, and no one was able to differentiate whether Bitcoin is whole blockchain or blockchain is a whole Bitcoin, or there can be other applications also, and no one has idea like the blockchain can become so much popular and becomes a very much trustable and immutable network that everyone tries to implement their applications that are required to be secure and trustful. Nowadays, if we see, every bigger organization is trying to bring their application and ideas on blockchain network. Why? That we already discussed. Blockchains are immutable. Once records are recorded into the blockchain, they cannot be changed. That provides very much security to your data, your transactions, and brings a network of trust where applications can easily invest and forget about the security and virus and other hacking worries. When you talk about blockchain, the entire industries also know that every transaction recorded on blockchain is completely auditable and all the nodes recorded are well validated and follow all the business rules and business logics that a business application is needed. Also, Bitcoin and blockchain, how they are related and how they are differ. So let's see what Bitcoin is and what was its era. Even this era time also can be considered as Bitcoin era only because it is again still booming in form of a cryptocurrency and stands very strong against all existing currencies like dollar, pounds, and any other. So let's learn about the history of Bitcoin and its detail of Bitcoin. In 2008, Bitcoin.org was registered by Satoshi Nakamoto. Bitcoin, a peer-to-peer electronic cash system, white paper posted in October 2008, and that was the first time when world came to know about blockchain or Bitcoin. In 2008, Bitcoin kept growing and Satoshi mined the first Genesis block of 50 Bitcoin in January. The first block in the Bitcoin blockchain, as we all know, is called Genesis block. So the first blockchain Bitcoin's length was 50 Bitcoin containing Genesis block. Bitcoin 0.1 released on cryptography at netsdao.com and Usenet. Then coming to 2010, first offline transaction of 10k Bitcoin for 2 pizzas was done successfully. And first specialized GPU hash miners and pooled miners operation was also successfully done. In 2011, continuing the journey of Bitcoin, it took parity with US dollar first time ever. It came into existence as a global currency. $31 top of first bubble followed by the first price drop. 2012 December $13 slowly rising for a year as it was really fluctuating. So during history of Bitcoin it kept fluctuating yet kept creating history in the financial market and showing people the strength of blockchain. In 2013 November Bitcoin broke $1,000 in second bubble. It was a peak for Bitcoin currency, but sadly in December 2013 prices crashed again to $600. In 2014, prices fell again following the shutdown of Mt. Gox impacting the Bitcoin market. Bitcoin continued to fall due to a false report regarding Bitcoin ban in China. There were various fake news around Bitcoin. People were not secure. False news were generated by the financial markets. It is online money. It's not secure. Hackers are driving it. Blah blah blah. In April, it started stabilizing at $450 after a long time. After a long fall, it stabilized at $450 value. In 2015, prices fell again through to early 2015. Large spike in value from 225 to 250 at the start of October to 2015 was recorded, and the record high was $504 in 2015. Price again stabilized to low $600 range in 2016 as the Chinese renminbi depreciated against the US dollar. Bitcoin rose to the upper $700 during this period, and renminbi depreciated against the US dollar. Bitcoin rose to upper $700 again. In 2017, prices fell 30% in a week, reaching a multi-month low of $750 again, and prices broke above the November 2013 high of $1242 and then traded above 1290 again. That was again a good first highest of Bitcoin. Price reached its maximum in the history of Bitcoin, reached all-time high of ever $12,500 in 2017. So that was all about history of Bitcoin, how it started moving in the market, how it captured the market, it became popular, how it fell and rise in the market, and were the values it attained during its whole history. Even in these days, Bitcoin stands strong against dollar. And if we talk about the current value of Bitcoin in dollar, so in today's date as well, it stands strong against dollar and has value of 3,857 US dollar. So really stands strong in nowadays as well and still growing. And one Bitcoin is equivalent to 3,857 US dollar. So you might have heard the people invested that time initially in the blockchain and the Bitcoin are really went into very good amount of profit, and it was having a boom at that particular time. Along with Bitcoin, there were multiple other cryptocurrencies that evolved and attained a very good value, and even sometimes they even defeated the value of Bitcoin in the market. So, if we talk about Bitcoin, the first blockchain focused decentralized digital currency was Bitcoin. Uses consensus to control its creation and management rather than relying on a central authorities, that is role of mediator, held electronically in a P2P open ledger called the blockchain. That was the first ever blockchain developed. The first ever idea of blockchain. They are not printed. They are produced by people using software that solves mathematical problems. And those mathematical problems are called consensus. Those puzzles are used in order to create new blocks inside the network and as part of the award against the creation of new block. Why to use bitcoins? It is super fast. As we all know, there is no mediator. Transactions are instantaneous. If they are zero confirmation transactions, or they can take around 10 minutes in a merchant requires confirmation. They are really cheap. Bitcoin transaction fees are minimal, and in some cases they are free too. It's absolutely decentralized. Because the currency is decentralized, you own it. No central authority has control over bitcoins. They are autonomous and free inside the network. Never worry about chargebacks. Once bitcoin has been sent, they are gone. A person who has sent the bitcoin cannot try to retrieve them without the recipient's consent under any circumstances. That means if you have spent your bitcoin and transferred it to some other person, you cannot retrieve it back. You cannot claim it back because there is no central authority. You have to request the recipient of the money or Bitcoin in order to send it back to you. Otherwise, there is no option. If your Bitcoin is gone, then it is gone. It also acts as the best payment security. Transactions don't require you to give up any secret information. They use two key public and private keys that are given at the creation of your node and your wallet. It is not inflationary. Bitcoin has been assigned a hardwired value of $21 million in its protocol itself. So any time in its lifetime, it can achieve maximum value of 21 million that can be created until it is itself changed in the protocol from from 21 million to some other value. But till date, it can grow to 21 million only. It's really private. It is like having it's plastic wallet with no visible owner. Everyone can look inside it, but no one knows who owns it. Make your own money. You can certainly buy bitcoins in the open market, but you can also mine your own if you have computing power. You can participate as a validator node and solve the problem. Proof of work can be used to solve the problem, and if you are a winner, you will be rewarded with the bitcoin by solving the problem. Now, where and how to get the bitcoins? In order to sell or buy a bitcoin, customer has to join the Bitcoin blockchain network. You can buy the Bitcoin using your wallet, your credit card, or online also. To start with, a user must install a virtual wallet onto a PC or mobile device. The wallet keeps track of your Bitcoin balance and all transactions. Bitcoin can be bought either through online payment or through any company. Once the funds are available, a buyer can place an order for a Bitcoin, similar to trading stocks, through various online exchanges, and then it can start participating in the blockchain network. Bitcoin can also be purchased from third parties, which sends the coin directly into your virtual wallet. Every time you transact, you will be using your wallet address in order to buy or sell Bitcoins. Bitcoin and its client. To join a Bitcoin ecosystem and start using a cryptocurrency, all the users are required to do is download an application or use a web-based application that is client. There are three kinds of clients available in order to transact with the Bitcoin: full client, web client, and lightweight client. Full client stores the complete history of Bitcoin transactions and manages the user's wallet and capable of initiating transaction directly on the Bitcoin network. That means it has full access and full role inside Bitcoin network and can manage the transaction and keep record of them. Web client. Web clients are accessed through a browser and stores the user's wallet on a server owned by a third party. They are used by exchanges primarily. So you can open a web client, do your transactions on a Bitcoin using third party user's wallet. Then comes lightweight client. This type of client stores the user's wallet but relies on third party owned servers for access to the Bitcoin transactions and network. So there are three kinds of Bitcoin: full client, web client, and lightweight client available with the help of third parties or maybe Bitcoin network to allowing you transaction over Bitcoin network. Bitcoin wallets. So as we discussed about Bitcoin wallets and Bitcoin currencies, we should know how these wallets are created and how they are stored against and for each pair. There are various Bitcoin wallets or clients available in the market. Web wallets. Web wallets are website or even online exchanges that allow storage. Example blockchain.info, Coinbase. So these web wallets you can use online and store your Bitcoin currencies. Mobile wallets. A smartphone wallet makes it really easy to scan QR code to make quick payments via phone only. No need to go to the browser for same. Example stands Bread Wallet, Mycelium, Airbits, Greenbits, etc. Since now we are very friendly to our mobile phones, gadgets, so mobile wallets are introduced, and like Paytm and other apps, you can use QR codes of your Bitcoin and do purchase and sell over the Bitcoin network. Then comes desktop wallets. Similar to mobile wallets, they use apps installed on a personal computer like desktop or laptop, and they act as a wallet to transact on Bitcoin network. Example, Electrum, Multibit, Armory. Hardware wallets. A piece of hardware is used to store the private keys to your Bitcoins. Example, Ledger Nano and Trezor. So you are storing your private keys in a hardware wallet, and that can be used for further transactions. Then comes paper wallets. It is the most secure cold storage solution that is used for storing your private keys and can be used as a wallet for Bitcoin transactions. Example, Coindesk Bitaddress. Then multi-signature wallets. These wallets require multiple private key signatures to make a transaction. That means you need to have multiple private key signature before you initiate and sign your transactions over the Bitcoin network. Example are Carbon Wallet, Coinbase, Blocktrail, Electron, and CoinKite. More details about these wallets can be found on web. Those who are interested in reading the details of these kind of wallets, how these are developed, designed, and used for storing the Bitcoins. So this slide shows comparison between different kind of wallets. If you see here, we have web interface, mobile app, desktop client, independent wallet, privacy, security, newbie friendly. All these criteria and features can be compared again each kind of wallet available. We can have hot wallet, we can have hardware wallet, we can have again multiple type of hot wallets to store our Bitcoin or payments. So in your hot wallet, web interface are available. In some of them it is available and some it is not. Mobile app for some of hot wallets are available. For some it is web client, that's desktop client available. Then in all kind of wallets you could see privacy and security is same and good because they are operating on blockchain networks. So these are example of different kinds of wallet that you can see what features they provide and what features they do not provide. So if we talk about the features and comparison of these wallets, you could see and follow the below table. Web wallet is unsafe, easy for beginners, very convenient and free of cost. While mobile wallets are unsafe, again easy, very convenient and free of cost. So using web and mobile wallets is not suggestible. Desktop wallets are safe, bit complicated for beginners, average in convenience and again free of cost. Hardware wallets are very safe. they are little complicated, and if we talk about convenience, they are not convenient and they require certain amount of cost to be spent in order to use hardware wallet, maybe 90 to 400 US dollars. Paper wallet. These are considered again very safe and really difficult for use for beginners, non-convenient and usually free. Then multi-signature are again safe, difficult to use for beginners. Convenience varies as per the uses of multi-signature wallets and is again free. So this was all about wallets. Let's see what all wallets exist following these types of wallets. Jack's wallet. Now that we have discussed and compared various Bitcoin wallets, let's see a wallet in working called Jack's wallet. Jack's wallet is used for Bitcoins, and when you log in to use it, this is how its home screen looks like. You can create new wallet or you can restore your existing wallet using the UI. Once you press on continue, you get a next screen where you can receive Bitcoins from senders, or you can also become sender and send Bitcoins. And there is also a QR scanner code available that can be used for easy transactions using this wallet. In turn, this wallet will show your balance also in terms of Bitcoin and in terms of US dollar. The second section of this Jack's wallet shows your transaction history, the number of transactions that you have done, you own the Bitcoin, and along with the details. So when you start sending your Bitcoins from Jack's wallet and you click on the send, you have to enter the recipient address, the amount of Bitcoins you want to transfer, and then you have to click send in order to send the Bitcoin. So procedure for sending the Bitcoin, as is summarized in the last picture, using the Jack's wallet, you have to click on the send button. In the address section, that you have to paste the Bitcoin address of the person you are willing to send the Bitcoin and the amount you want to send, and then click the blue icon for send and sending the Bitcoins. Even if you want to generate or receive Bitcoins through Jack's wallet, you have to click on receive. You have to click on the amount that you want to generate and receive from the address. So step 4, you request your payment using your QR code, or you can give your address for the transaction, requesting the Bitcoin for that particular amount. Okay, so this is how you can send and receive Bitcoins using your Jack's wallet. There are other similar wallets exist in the market which have similar functionality as of Jack's wallet with some different GUI. Now, the second important point comes to secure your wallet. How you are going to secure your Bitcoin wallets. There are multiple ways to secure and make your Bitcoin wallet more secure. You can encrypt the wallet in order to protect your wallet from prying eyes is to encrypt it. This makes it difficult to access your wallet but not impossible. You have to use public and private key pair in order to encrypt the wallet, and while using you have to use a decrypted version of it. You can use multisig that allows multiple parties to partially seed an address with a public key. The required number of signatures is agreed at the start when people create the address, and that is more secure as compared to normal encryption of the wallet, where you are using multiple signatures, that is used by multiple seeds and peoples in order to create a signed address. Third option is you take a backup of it. Backing up your wallets makes a copy of your private keys, but it's important to back up your whole wallet. You can also take it offline. Cold storage wallets store private Bitcoin offline, and they are not accessible over internet, and this also makes it secure, that is available to you only. How to buy your first Bitcoins? It is still quite difficult to acquire Bitcoins in most countries. Cryptocurrency exchanges are the easiest way to buy Bitcoins. So you can do them. You can buy your first Bitcoin using Bitstamp, a European currency market that supports several currencies including euros and US dollars via wire transfer. You can use Coinbase, a US-based Bitcoin wallet and platform where merchants and consumers can transact into Bitcoin. ZipPay. ZipPay is the fastest and easiest way to buy and sell Bitcoins in India. So if you want to purchase and sell your Bitcoins in India, you can use ZipPay. CoinSecure. CoinSecure is the most secure Bitcoin exchange to buy, sell, and accept Bitcoins over internet. So these were some sort of mechanism, some sort of options using which you can buy your first Bitcoin over internet. And all our options available are using cryptocurrency in order to exchange your Bitcoins in easiest manner. Now, how to sell your Bitcoins? You have option of selling the Bitcoin in two manners, selling Bitcoins online or selling Bitcoins in person. How to sell Bitcoins online? There are three ways to do so. Direct trade involves a trade with another person directly over internet. Exchange trades involves an online exchange where you can trade with the exchange rather than another individual or any unknown person. So you are doing Bitcoin exchange or selling in form of exchange, trading over the internet. Peer-to-peer node or peer-to-peer trade allow Bitcoin owners to obtain discounted goods with their Bitcoin via others that want to obtain the cryptocurrency with. So they are trading in Bitcoin. You have option to trade in Bitcoin. You can buy discounted goods with your Bitcoin over internet via others that want to obtain cryptocurrency in return. These are few examples of selling Bitcoins. Online with exchanges, websites that offer this type of selling model include Coinbase and local Bitcoins in the US and BitBargain UK and Bitlicious in the UK and many other exchanges across the globe. You have option to transfer or sell Bitcoins peer-to-peer. Again, the marketplace acts as an intermediary, offering users the platform, Bitcoin wallet, and escrow for transactions. So these are some examples of selling Bitcoins, online or offline. But beware of using website for transacting into Bitcoin. There are various fraudulent websites available in the market online that may cheat you and exploit your internet in order to hack your system and spoil the Bitcoin amount available in your wallet. So you need to be very careful while sending your information and transacting with online parties that simply anonymous to you. Always buy and sell Bitcoin from authorized vendors. So this screen shows various places to spend Bitcoins. One example is Bitcoin Store, where you can buy multiple items in exchange of Bitcoin, and that acts as a online marketplace that sells a variety of electronic gadgets. Then you have BitPremier, luxury Bitcoin online only marketplace where you can find anything from high performance sports cars to work of art and even real estate also. Then you got gifts, that is used to buy, receive, redeem, and send digital gift card for over 200 retailers including Amazon and Sears, Target, and GameStop. So gift is used to buy coupons or digital cards, gift cards. Now they accept Bitcoin also over other payment options. Other option available is CoinGig that again allows you doing transaction in form of Bitcoins that conducts transactions solely in Bitcoins only. You can find everything from books to t-shirt to gift vouchers on CoinGig. Then you got Virgin Galactic, cheapair.com. These are other options where you can utilize your Bitcoins in order to purchase items from marketplace. You got Bitcoin commodities, travel. Bitcoin commodities helps you sell gold and silver coins, bars and sheets. As the name suggests, it accepts Bitcoin payments. While travelforcoins.com acts as a middleman between you and travel sites such as Expedia. You pay in Bitcoins to travel for coins who will pay for your flights using standard currency. That was all about the places where you can spend, sell, and purchase your Bitcoin. Bitcoin blockchain, transaction, and transaction script. So, before spending the Bitcoins, we should be securing them inside our Bitcoin wallet. That we already learned. Now, what is Bitcoin blockchain? Transaction and transaction script that we'll be learning here in coming slides. Now that we have seen how a Bitcoin is used and spent, let's see what exactly happens when a transaction occurs. There are various Bitcoin protocols that can be used while doing transactions. Mining, research and support, payments, retail, buying, selling and storing, financial services. So these are the areas where Bitcoin's ecosystem can be used. Your mining, hardware manufacturing, mining platforms. You can use it for foundation, for profits, venture capital, security. You can use it Bitcoin protocol for payment processes, escrow services. Then you can use for retail services like merchants, directories of stores that accept Bitcoins. You can use Bitcoin's protocol for exchanges, software wallets, market makers, ATM providers, and then you can use them for financial services as well, like institutions, lenders, insurers, hedge funds, and then for products, derivatives, and investments. So these are examples of using Bitcoin protocol for various kind of applications and services. The structure of Bitcoin transaction. A transaction contains a number of fields. As you can see here in the tabular format, like it contains every Bitcoin transaction contains a version which is size of 4 bytes and that specifies the rules this transaction follows. Then you got input counter in the Bitcoin transaction field that is of 1 to 9 bytes variable integer and it includes how many inputs are included in the transaction. Then outputs. You get variables to store outputs for one or more transactions. Then you get 1 to 9 bytes variable integer type of output counter that is used to count how many outputs are included. Variable outputs is used to store one or more transaction outputs, and then log time is a Unix timestamp or block number that is used to save the timestamp of the transaction in 4 bytes. Unspent transaction output. How an unspent transaction looks. UTXO or unspent transaction output is a fundamental building block of a Bitcoin. An unspent transaction output that can be spent as an input in a new transaction. The network keeps track of all available UTXOs, currently numbering in the millions. So these are the stored coins or Bitcoins that are available in your Bitcoin network that are unspent and stored as a form of unspent transaction output. The first block contained 50 mined BTC in address A is equal to 50. The second block contained 50 mined Bitcoin in address A. A transaction sending 20 Bitcoin to address B and putting the change in address C. So in that way A was 50, your B becomes 20 and C has a value of 30 Bitcoins. The third block contained 50 mined Bitcoin in address A. A transaction sending the 20 Bitcoin from address B to address D are available. So after 3 blocks, you could see there are 4 unspent outputs. A has 2 unspent output worth Rs 50 Bitcoin each. C has a single unspent output worth Rs 30 Bitcoin and D has a single unspent output worth Rs 20 Bitcoin. And there are 2 spent outputs also. The 50 Bitcoin generated in the first block is spent in the second block. The 20 Bitcoin output created in the second block and spent in the third block. So what do you see here? Let's review the example again to explain into more detail. The first block was A and was having 50 mined Bitcoins. The second block was containing 50 mined Bitcoin in address A, a transaction sending 20 Bitcoin to B. So this 20 amount got deducted from A50 and putting the change in address of it. So it becomes A has 50, then B got 20 Bitcoins and the C becomes 30 in reduction of 20 Bitcoins. The third block contained 50 mined Bitcoin in address A. A transaction sending the 20 Bitcoin from address B to D is used now. So your A got 50 plus 50 Bitcoins and now C was 30 again and D got 20 Bitcoin transferred from B. So these are the values in this third block. Note that unspent outputs don't merge together. The two unspent 50 Bitcoin outputs at address A are separate and will remain separate at least until they are spent in a transaction. So each unspent transactions are stored separately and should not be merged together during the transaction. Bitcoin transactions input and outputs. Firstly, 4 axiomatic truth about transactions. Any Bitcoin amount that we send is always sent to an address. You need to have recipient address in order to send any Bitcoin. Any Bitcoin amount we received is locked to the receiving address and should not be used, which is usually associated with our wallet. So the amount of Bitcoin we are sending to other party will be locked from our wallet until it is successfully sent to the recipient. Anytime we spend Bitcoin, the amount we spend will always come from the funds previously received and currently present in our wallet. Address receive Bitcoin, but they do not send Bitcoin. Bitcoin is sent from a wallet. So that are 4 thumb rules or truths about transactions occurring for Bitcoin transactions. So this block of code shows Bitcoin transaction example. In the block, you got 3 blocks. The first block has hash of the transaction, then version of it and other details. You got in block section and out block section also into the transaction example. Transaction format version is currently at version 1. If you could see from the figure, in counter is the number of input counts that are available to this transaction and output counter is out counter, that is number of output amounts. You could see here the output amount and input amount are defined as discussed. Transaction lock time should be 0 or in the past for the transaction to be valid and included in a block. Then size of the transaction in bytes. So these are the information that are present as in the header of the blockchain transaction example. Bitcoin transaction input and outputs. So the amount that goes into our wallet are not jumbled like the coins in a physical wallet. These amounts received don't mix but remain separate and distinct as the exact amounts received by the wallet. Here's an illustration. Just see an example. You create a brand new wallet and in time it receives 3 amount of 0.01, 0.2 and 3 bitcoins as follow. You will send 3 bitcoin to an address associated with the wallet and 2 payments are made to another address by Alice. If you see in the figure, 2 people send amount to addresses held by a bitcoin wallet and the wallet balance for this wallet was initially 3.21 Bitcoin, adding 0.01, 0.2 and 3 Bitcoin in your wallet. Now, these all amounts came from 3 different resources from Alice, then Alice and you. Now, The wallet reports a balance of 3.21 by summing up the amount. Yet, if you were to virtually speak inside the wallet, you would see not 321 million Satoshi, but three distinct amount grouped together by their originating transactions. So by this, we can conclude that each amount added to the wallet are kept separately. The received amount, bitcoins, don't mix but remain separated as the exact amount sent to the wallet. The three amounts in the example above are called the outputs of their originated transactions, and Bitcoin wallet always keep outputs separate and distinct. This should be clear by now. We should not be summing up the amount of currency or Bitcoin received. Transaction inputs. Transaction inputs are pointers to UTXO. They point to UTXO by reference to the transaction hash and sequence number. Until now, we understand what are hash. I will try to elaborate it more using a demo and example. So, hashes are, as discussed, are the mechanism using which you can create your strings encrypted format, and that are, when hashed, create a unique value that changes when your input string changes. So hash of any given string is always unique and can never be generated using any difference inside the string. I will show you how you can test and generate hash. You can go to any online website and start. I will just take an example of this example website where you can go and generate hashes and play with it according to your learning and as per your interest in this topic. You can give any data in this comment box or text box. Say hello. So if you see here, even if it was empty, it was having a hash value. So empty string also has a hash value and is always of a fixed length. Here in this demo, we are using SHA-256 hash. So SHA-256 is always considered a very strong hashing mechanism that is almost impossible to hack and translate. So if you see, hello generates a unique hash string. And if we try to change it by a dot even, the whole hash changes. So this way, hashes always remain unique and you can always use them to preserve the validity or authenticity and integrity of your data blocks. So this was an example of hash. Let's move to the parent topic again. So your transaction inputs are pointers to UTXO. UTXO we know, unspent transaction outputs. They point to UXO by reference to the transaction hash and sequence number. To sell or spend UTXO, our transaction input also includes unlocking scripts that satisfy the spending conditions set by the UTXO. Every transaction input has the following field. It has transaction hash pointed to the transaction containing the UTXO to be spent. Then it could be of 32 byte size. Then output index, the index number of the UTXO to be spent. First one is always 0 and its size is 4 bytes. Then unlocking script size. Unlocking script size length is in bytes to follow. It can vary from 1 to 9 bytes. Then unlocking script, a script that fulfills the condition of the UTXO locking script and it is of again variable size. Then sequence number. Currently disabled transaction replacement feature set to hexadecimal value 0xFFFFFFF. And this is again of size 4 bytes. So these all fields constitutes your transaction input block. What does a transaction look like? A transaction has three pieces of information. In this example, you can see it has in signed public key, out, and the amount of the Bitcoin that is being transferred. So the input is a record of which Bitcoin address was used to send the Bitcoins to the customer in the first place. Then amount is the amount of Bitcoin that A is sending to the vendor. Output is the Bitcoin's address of recipient Bob. So these three transaction fields constitute your transaction block. Each input and output field is using the address of the sender and receiver node, or you can say peers. Any transaction is signed using sender's private key and it uses the address of the receiver in order to transfer the amount to the recipient. So this whole figure depicts the same that we discussed. 2 Bitcoin is sent to the address of the customer and at in node it is signed with the key. Then output is sent to the address of the vendor, the amount 2 Bitcoin and 3 Bitcoin is again sent to the address of the customer change. Now example to show the transfer of Bitcoin. Let's say Andy has 3.21 Bitcoin in his wallet sent to him at different addresses. So these amounts were sent from Alice, me, you or Alice again. So these all have different addresses and they send the balance to Andy and constitute 3.21 Bitcoin in his wallet. The received amount remains separated as exact amount sent to the wallet, if you can see here in the figure, and that is called transaction output. Spending consumes UTXOs and creates new ones. You could see from the figure before balance of node 1, or you can say the sender, was 3.21 Bitcoin. So when he tried to sending 0.15 Bitcoin to Bob, it destroys output of amount 0.02 Bitcoin from the transaction, or you can say UTXO available in his wallet, and creates a new output of amount 0.05 Bitcoin inside the wallet of the sender node. So whenever a transaction is initiated, it looks the nearest value available in the wallet and it deducts the money from that portion only, from that address only for spending. The above scenario explains the 0.2 value was nearer to the 0.15 Bitcoin required to send to the Bob, and this amount was deducted from this particular address only and leaves 0.05 balance after the spend. So 0.15 Bitcoin will be sent to Bob's address and will reside in his wallet as an output, waiting eventually to be spent. The 0.05 Bitcoin is called change and will be sent back to your wallet. So you see the whole block, the whole address amount was translated and transferred to the Bob, and this amount, the change, the remaining portion was returned back to the wallet as new address. Transaction as double entry bookkeeping. With the previous example, it is clear that the transaction in Bitcoin is a double entry bookkeeping. How? Let's see in the given diagram. This is a specimen of a double entry bookkeeping. You got inputs, you got outputs. So you have entry for both in form of bookkeeping. You got four inputs, input 1, 2, 3, 4, and each has different value of 0.10 Bitcoin, 0.20 Bitcoin, 1.10 Bitcoin, and 0.15 Bitcoin respectively. Then your output entries are three, output 1, 2, and 3, and these have again different values of 0.10 Bitcoin, 0.20, 0.20 Bitcoin again. So when we sum up the total inputs and outputs, we come across total inputs of 0.55 Bitcoins and total outputs of 0.50 Bitcoins. So when we calculate the difference, it is 0.05 Bitcoin, and this is implied as transaction fees. So if you see, the amount of transaction input can never be equal to the transaction output because our difference is applied, that is called transaction fees, for completing the transaction. That is why it is called double entry bookkeeping, because it stores both the entries of input and output blocks and do all the calculations for transaction fees. Bitcoin transaction lifecycle. How Bitcoin transaction lifecycle starts and flows till the end, that can be depicted from the given figure. We start here. Rob opens his Bitcoin wallet, scans copy Laura's address in order to send the money. What Bob is doing, Bob's quest to send 0.3 Bitcoin to his friend Laura is an example of this whole Bitcoin lifecycle. He's trying to transfer 0.3 Bitcoin to his friend. He opens his wallet, scans the address of Laura in order to send the 0.3 Bitcoin, fills the amount and the fees of transaction, and then sends over the network. Then it passes through user or machines, and the wallet signs a transaction using Rob's private key. This transaction before sending over the network is signed using Rob's private key, and it is all time spent 10 seconds around until now. The transaction is propagated and validated by the network nodes. Miners or validators include the transaction in the next block to be mined. So this transaction is now part of group of transactions of a new block that is being mined by the validator nodes. We all know that mining is the computational process of calculation of certain hashes and take time. So when mining is done, the miners who solve the proof of work propagates a new block to the network and new bitcoins are created in result. The nodes then verify the result and propagate the block and add to the blockchain. When the final confirmation is done and blockchain got the new block added, Laura can see the first confirmation on his wallet and his device that the amount has been transferred successfully and received by her. New confirmations appear with each new block that is created. So every node inside the blockchain network is made aware of the new block creation, and this constitutes the whole life cycle of a transaction inside a Bitcoin transaction life cycle. Now we'll be discussing about various transaction forms in Bitcoin. Let's see what are the various type of forms used in Bitcoin transactions. This is the figure depicts a common transaction form. The most common form of transaction is a simple payment from one address to another, which includes some change returned to the original owner. So this is a very basic example of transferring Bitcoin from one address to other, where input 0 from Alice signed by Alice is sent to output 0 to Bob, and then output 1 comes as change returned to the Alice. Then comes aggregating transactions. These are another common form of transaction where transaction is one that aggregates several inputs into a single output. So what happens? Multiple inputs are aggregated and formed in a form of transaction and sent to output 0 to the output peer or output node. These type of transactions are sometimes generated by wallet applications to clear up smaller amounts that were received as change for payments. Then comes distributing transaction. Transactions that distributes one input to multiple outputs represents multiple recipients. So here the sender address or sender peer can try to send amount of Bitcoin to multiple addresses in one transaction itself. So you can generate one input with multiple items to multiple recipient addresses, and this will be further distributed in multiple outputs depending on the number of different addresses available. So this type of transaction is sometimes used by commercial entities to distribute funds, such as when processing payroll payments to multiple employees. So this is a quite good example where this can be used by an organization to send salary of multiple employees inside their organization, which will have all employees have different addresses in the network. What are scripts in Bitcoin? Now that we know that transaction in Bitcoin consists of input and outputs, these inputs and outputs offer nothing but the scripts. Bitcoin scripting language script. All Bitcoin transactions have scripts coded into its inputs and output mechanism. Design goals are forth-like programming language, old stack-based simple programming language used, reverse polish notification. Data is pushed onto the stack and operation is performed. Composed of OP codes. Operation in Bitcoin is composed of OP codes or operation codes that help deciding the results. Example of Bitcoin scripts you can see on the screen. The script shown alongside will execute the values in the stack and will return to value to true if the equation is valid. So it has multiple steps to execute it inside the script. The scripts are written in the old stack-based programming language that is called Forth or other similar programming languages. They have syntax, they have execution pointers, execution starts from the left, that constant value 2 is pushed to the top of the stack. In the third step, this execution continues moving to the right. With each step, constant value 3 is pushed to the top of the stack. You can clearly see that data structure stack is used here in order to propagate the script execution. Then the add option specifies adding the values. Operation add pops the top two items out of the stacks are added them together, and then operator adds pushes the result 5 into the top of the stack. This is syntax of this programming language that is used to calculate the value and propagate the transactions. When the script shown alongside is executed, the result is op-true code, making the equation valid. That means the constant value 5 is pushed again to the top of the stack that was received as a result of adding 2 and 3. The operation equal pops the top two items out of the stack and compares the value 5 and 5, and if they are equal, the equal pushes true, or if they are not, it will be 0. Most common script types. Pay to public key hash, P2PKH. One of the most commonly used transaction output script. It is used to pay to a Bitcoin address. Second is pay to public key. This is the simplified form of that P2PKH. This is not commonly used in new transactions anymore because P2PKH are more secure. Pay to multisign, P2MS. Multisign outputs allow to share control of Bitcoin between several keys, and that makes them more secure, that we have already seen in previous sessions. Pay to script hash. Scripts that contain the hash of the another script called redeem script. And it is another way of common script types using transactions. Script mechanism. Transaction validation engine relies on two types of scripts to validate the transaction: lock and unlock. Unlocking script sig that signs using public key, and while plus locking script is script public key that uses duplicate hash 160 public hash equal verify and check the signature. That is the function written and for locking and unlocking script. Unlock script, a script sig is provided by the user to solve the encumbrance, while in locking script, lock is found in a transaction output and is the embrace that must be fulfilled to spend the output. Combining the output and input scripts. The two scripts together would form the following combination validation script. Cafe signature, cafe public key output dup op hash 160 and cafe public key hash op equal op check sig. The script combined, when executed, will evaluate to true if and only if the unlocking script matches the conditions set by the locking script. So this is just an example of writing codes in your input and output scripts. When you have your own requirement, you can simply code, and obviously you should be having the knowledge to write in the code, and then you can evaluate and get the value accordingly true and false by meeting the certain condition allowed by the locking script to the unlocking script. The result will be true if the unlocking script has a valid signature from the cafe's private key that corresponds to the public key hash set as encumbrance. Now, here comes the evaluation of the script. So on this screen, you could see how steps provided in the scripts are executed and evaluated. Pointer is at the initial state saying. So signature sign off happens using the public key. Evaluation starts. Value sig is pushed to the top of the stack. Then public key is pushed and execution continues moving to the right with each step. Value public key is pushed to the top of the stack on top of the signature. And this algorithm is repeated continuously till the end of the steps. A step-by-step execution of the combined script which will prove this is a valid transaction. In the next step, dup operator duplicates the top item in the stack. The resulting value is pushed to the top of the stack again. So for the audiences, those who are not into development, this could be a bit tricky. They should know how push and pop happens from the stack and how operations are performed over the stack data structures. So the scripts are simply following the data structure instructions. They are pushing the items into the stack, doing pop and push items in order to execute the instructions written. The next item, hash 160 operator, is picked and it hashes the top item in the stack with the repmd 160 SHA-256 public key. The resulting value pub k hash is pushed to the top of the stack now. That is received by hashing. Now the value pubk hash from the script is pushed on top of the value pubk hash calculated previously from the hash 160 of the pubk. The equal verify operator compares the pubk hash encumbering the transaction with the pubk hash calculated from the user pubk, that is public key, and if they match, both are removed and execution continues. The check sig operator checks that the signature matches the public key and pushes true to the top of the stack if true. So since the script alongside returns true, this transaction is valid. Otherwise, it stands invalid. So this is how any script works. Any Bitcoin script works and calculates the transaction values. Nodes in Bitcoin network. So since we have discussed more about transaction inputs and output and the scripts, we will see now what are the various nodes in Bitcoin network. In the Bitcoin network, full nodes are the enforcers of consensus rules, but not all full nodes are created equal. There are several different kinds of Bitcoin full nodes which exist in the ecosystem. Pruned selfish full nodes. A pruned node is a full node that prunes raw block and undo data by deleting it from the disk. This can be achieved to save the disk space. A selfish Bitcoin node is a node that does not upload new blocks or transactions to the other Bitcoin peers in the network. Archival selfish full nodes. An archival node is a full node that stores a complete copy of the Bitcoin blockchain data on the disk. Within this data, the archival node operator can make queries against the blockchain to find information pertaining to the particular transaction or addresses. Common Bitcoin nodes in the Bitcoin network. Network result routing node, full blockchain. If you see here, you could see reference client that contains Bitcoin core. Then you got full blockchain node. You can have a solo miner. You can have lightweight simple payment validators wallet. Then you can have pool protocol servers, mining nodes, lightweight SPV, Stratum wallets. So the network routing node contains a full blockchain database and network routing node on the Bitcoin P2P network. This reference client contains a wallet, miner, full blockchain database, and network routing code node on the Bitcoin P2P network. Solo miners contains a mining function with a full copy of the blockchain and the Bitcoin P2P network routing node. Lightweight SPP wallets contains as a wallet and a network node on the Bitcoin P2P protocol without a blockchain. Then comes your pool protocol servers. Gateway routers connecting the Bitcoin P2P network to nodes running other protocols such as pool mining or Stratum nodes. Example, pool server, Stratum server. Then mining nodes containing a mining function without a blockchain with the Stratum protocol node S or the other pool P mining protocol node. So one other type of common Bitcoin nodes is lightweight SPV Stratum wallet. Again, contains a wallet and a network node on the Stratum protocol without a blockchain. So here you do not need to worry. These are just example of common Bitcoin nodes that are used in Bitcoin network, and there are many. If you're interested, you can really go through the web and read about the definition and example of these kind of nodes that are used in Bitcoin network.
Okay guys, we've come to the end of this session. I hope this session on blockchain was informative for you. If you have any doubts, feel free to comment about it below. Thank you.